You are listening to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson of Proteum Machining, and this week I am joined by the raddest of Robs, Rob Ellis. Welcome, Rob.
How's it going?
Pretty good.
Thanks for having me on here.
My pleasure. So for those who don't know who you are, what you do, all those details, tell us.
So, my name's Rob. I'm the director of manufacturing for Maztech Industries. So we're a company that, I guess at the core of what we do, we're basically an engineering company with the emphasis is engineering. And then we have our manufacturing leg of that as well. So, everybody at our company is kind of, likes to innovate new products and come up with some cool stuff. And so I get to be the lucky one to turn all of those ideas into reality. And it's a pretty fun thing to do. So,
yeah, it seems like you really get to play. You really just get to play on the machines. Like, you have to make stuff too, but like some of the stuff you post is just like, oh man, that's cool. I'd love to make something like that.
Yeah, no, we'll definitely get into that. Kind of what a wild ride it's been with my career with this company and kind of how I've grown through it and everything. So,
well, yeah, let's get into your backstory. How did you start in manufacturing? How'd you get to where you are now?
So I started in manufacturing, God, it's probably 15, 16 years ago now. I was actually I've been into cars my entire life. So I was working for a company. We sold race car parts, rear ends and suspension systems for Jeeps and things like that. And I was doing sales and tech support. And I kind of traveled around the country with some race teams and did some sales stuff and enjoyed that for a while. And then 2008, when the economy took a tank, people stopped buying parts for their race cars. And, I was the newest guy on the staff at the time. So kind of low-hanging fruit, I got cut from the team. So I was actually kind of searching around for a job. I didn't really have anything in mind. I knew I wanted to do something with race cars. And I was dating this girl at the time. And at her house one night, her dad had, kind of heard what was going on. And he said, hey, so we're looking for a machinist at our shop if you'd be interested. And the company I worked for, we had a machine shop, but they were all old manual lathes, lots of manual tooling. So I wasn't super familiar with it. So I said, hey, I don't even know what a CNC machine is, to be honest. And he said, you know what, why don't you come on by? I'll show you around the shop. He said, you're pretty good with your hands and, always working on stuff, wrenching on things. So he said, I think you could figure it out. So I went over to the next day and, it was a pretty small company. The company was called N2 Imaging Systems. And at the time, it was my then boss. His name's Jim. And we had one other machinist there. So it was a real small staff. And we had, God, I don't even remember now, probably 6 or 7 machines in there. They're all Haas machines. And he came in, showed me around. And literally my interview was, so anyways, this is the shop. You want to work here? And I said, oh, sure. I mean, I can't promise anything, great out of this. I don't know what's going to happen, but let's find out. So a couple weeks later, I showed up at the shop and it literally started out with him pointing at the green button and saying, this is how you turn on the machine. And that was literally my start where I picked it up. And so from there, I got my foot in the door and I'm kind of working, and pretty quickly I realized this is something that kind of piqued my interest. And, at first it was like, cool, it'll be a job that I can go work at until I find something that I really want to do. And obviously history shows it turned out what I did. The crazy thing for me though was growing up, I wasn't great in school. My head was always in the clouds. I couldn't focus. It was hard to, been obsessed with cars since I was a kid. So I just read all the magazines, back when magazines existed. And,
right. Motor Trend, Car and Driver.
Yeah. And,
I'm
going to get a lot of shit for this, but I was a Honda guy growing up. I still am a Honda guy at heart. We'll talk about car stuff later. I think I picked up you're into cars a little bit too.
Oh yeah, definitely.
So anyways, I used to cut out, this is my favorite car. I'd stick it in my binder and go to school and be like, look at how cool, just way into it. And then I landed this job and it's kind of interesting to me. It was this, you start reading drawings and you start having to pay attention to things and just all numbers. And I wasn't great at math. And I always struggled at math in school. I was really good at English and anything writing and that type of thing. And never thought this would be something I would be even slightly interested or good at. What I really enjoyed about it is my boss at the time is an old school guy, comes from way back in the day, And he's got all kinds of stories about it. And a guy like me, I could talk shop all day long with anybody, especially the older guys that have been doing it for 50, 60, 70 years, just. And so it was really cool. At the time, we didn't really have a lot going on. So I would come into work and it was like, all right, let's put fresh coolant in the machines. Let's check the taper on the tool holders. Let's just kind of clean the shop, do organization stuff. And then he decided, hey, you know what? Let's just pull out the whiteboard and start doing math. Let me show you guys how to figure out how to figure out true position without a calculator, without your phone. Let's do the long form math to do all this type of thing. Let's pull out the sine vices and let's get the Joe blocks. And let me show you how to set these things up to do inspections at angles and all this, and shoot it up. I could not take enough notes. I was loving it. And, that I probably did that for a few years. And along with that came all the learning how to machine and crashing the machine, breaking tools and, all the stuff you learn along the way. And, a couple years into it, I was kind of like, I enjoy machining. I'm getting okay at it. My biggest problem was I was really fast. So I was running across the shop, grabbing this tool, running back to the machine, loaded in the machine. I got to make as many parts as I can today. I want to show them how hard I work. All the while paying attention to tolerances, not reading the drawing, not checking surface finish, And so I remember one day my boss sat me down with the other machinist at the time, which is the two of us. And he said, I've got a problem with both of you. And he said, you, Rob, work insanely fast. I love how hard you work. I love how fast you work, but your attention to detail is shit. And I need you to clean that up. And the other guy said, your attention to detail is insane, but you are way too slow. So I need like middle ground of both of you guys, And so for me, it was, okay, took that to heart. I said, whenever somebody tells me I'm doing something wrong, you got to take a step back, look at it from their perspective. And I said, okay, he's got a point. And so I made sure I tried to keep up my pace. But of course, when you're going to start checking things a lot more frequently, it's going to slow down a little bit. So finding that balance of maintaining the quality we were expected to do and hit the top tolerances and, make good parts and make parts that you can take pride in, that's what came next. And so I really started enjoying that. And then naturally after that, I said, I want to start learning programming, and so then my boss was like, all right, let's sit down. Let me show you let's write a pocket program. Let's do an Op2 pocket, just a rectangle and a set of soft jaws. Easy peasy. It's literally as easy as it gets for programming. And I said, okay. And, hour later, we're sitting there in his office. This is Mastercam, I don't know, V9, V7. It's an old one now. Huh. And it was cool. I was like, oh my God, this is opening up a whole new world. And at the time, it was also, I had never done anything in CAD. All I have seen of Mastercam was when my boss would hand me a program posting it out of his computer. That's the only time I messed with Mastercam. So CAD was new to me, CAM was new to me, and I'm probably 2-3 years into machining, so I'm getting the hang of it. I'm learning machines and things like that. And I'll never forget, he showed me that pocket routine, and I said, I'm gonna go home tonight. I had a student edition of Mastercam. You could do everything in it, you just can't post out of it. And it's like this is before YouTube was. You could just hop on YouTube real quick and let me just go watch a tutorial on how to do this. So It was a lot of trial and error. And the funny thing about him too, my old boss, is he grew up. He worked on oil rigs. He was a police officer back in the day. He was a rough and tumble guy, and he had, I wouldn't call it a grumpy attitude, but he was a hard ass.
He was one of those old school machinists.
He was an old school machinist, exactly. And he was, threw things across the shop, was yelling when you screwed up. And the funniest thing about it was he would always say, if you slam a spindle into the table, I won't even get that mad. I just want to know what happened. But if you snap like an 1/8" end mill, he flew off the handle, throwing things across the shop. He's like, I don't know what it is about the big things. They don't bother me. Usually it's a mistake. It could be a program error, but it's the little things that just drive him nuts, Well,
so let me ask you.
Yeah.
How did he deal with mistakes? Like what? Because I know a lot of people are turned off by that of like, oh, these mistakes cost money and they're big. They can be very big stakes when I screw up. So, I mean, clearly he did have a temper, but what about it made you want to keep going? Because I think a lot of us are looking towards hiring and training, and that's a tough thing to deal with, is like, how do you deal with employee mistakes?
Yeah. And so we can get into how I handle them. Being that I've got a decent team under me now, and I've worked with a lot of guys over the years. I took the things that I liked about his management style and the things I didn't like about his management style and just kind of formed it into my own. But the way he handled mistakes was, I hate to say, he make you feel stupid about what you did, because that's not his intention. I think really what it's just trying to drive the point home. And it's one thing I've always carried with me, and it's one thing I always tell guys when they're training is, if they crash a machine, if I come over and ask you what happened, I want an answer. What happened? Even if it's, man, I forgot to set my tool, or I forgot to set the Z offset, I want to know what it was. I don't care if it was a mistake, but if you say, I don't know what the problem was, then, there's nothing from you to learn. There's no lesson there. It's just, you made a mistake and now here we are, we got to start over. So, it was always, when you make a mistake, if you had an answer for it, he'd still get pissed, but then it was like, all right. And he tries to take that as, all right, here's what happened. If it's a one-off thing, simple operator error, we move on from it. If it's a repeatable problem, all right, let's sit down. Clearly, we've got an employee problem here. We've got to sort this out. So it was a lot of sitting down with him when I was learning. But also, he had, I don't mean to paint a bad picture of him, because he still is my favorite boss I've ever had. I still talk to him to this day. He's retired now and moved out to Ohio, and he's, living out on the countryside. And I love the guy to death. He's an awesome guy. But yeah, so learning to program and coming to him, and when I have questions, it's like, oh shit, is he gonna give me, what are you doing here? Why did you do this? I wouldn't do it that way, And there were definitely those moments, or he furiously tapping the non-touch screen. It was always pointing, click here. It was hilarious. It's one of those things, and that's what I've always told guys when we ended up growing and we had quite a few more machinists in the shop. I always told them, ignore the volume at what he's telling you and just listen to what he's telling you. I understand he's screaming and his face is turning purple, but there's a message in that, and he was, I call it tough but fair. He was an awesome guy. But yeah, I think that's kind of is I think how we handle the mistakes was more kind of on a case by case basis. If you had an answer or a legitimate reason, and sometimes he was the only programmer at the time, so sometimes it was his fault, and
right.
And then of course we have to just sit there and go, I guess we'll just keep our mouth shut about this one,
Right.
And so I ended up taking it on myself I just wanted to learn to program, so I just spent a bunch of time, and I finally just kind of went in his office one day and I said, hey, I'm ready. I want to take the next step. I'm ready to step up and I want to do some programming. And a little hesitation at first, but he ended up letting me do it. And then from there, it was just everything exploded and kind of opened up this whole new world of, I really think machinists nowadays, I really think there's a lot of value in them learning to program. I know there's a lot of shops out there that kind of want to have these button pushers. They want them to come in, we pay you to stand at that machine all day. And I understand that. And there's definitely some shops that necessitate that kind of employee. But at least at this shop, at the time, at the shop that I'm at now, I always try to, at least have a moment with the guys to see what they want to do. If they want to do something, you got to give them some kind of, I don't know, some path to look forward to. A lot of these guys want to learn to program. They want to do different things. And some people are a little hesitant to step up and say that.
Right. Yeah. So but you got to have some kind of upward mobility potential, at least.
Exactly.
Even if you don't take it. Yeah.
And really, you have nothing to lose. You say, all right, I'm going to teach this guy to program, and you start programming, and hey, it's not really working out. Oh, we gave it a shot. Or, hey, it's working out. It's just going to be a little bit slower. So we'll just be patient about it. Or, hey, this guy is, should have had him programming a long time ago,
Oh, yeah.
And so, so I think that's kind of what sort of introduced me to programming. And, programming in Mastercam was exclusively where we did everything. And, again, so this is a company that's full of engineers. That company's owned by an engineer, where 90% of the employees are engineers. And we always made the joke that the machine shop was we're assistants to the rock stars. We're the machine monkeys. We're the locker room of the company.
Right.
We're the loudmouthed machinists that are, it's that type of thing. But everybody, it was great because it kind of felt like one gigantic collaborative team, sort of driving towards that same goal. As cheesy as that sounds, there were times that it really was kind of fun. And for me and wanting to learn different things, I mean, there's so much brain power to just go ask questions, and you find pretty quickly that some people are more than willing to help you out. Some people aren't, but you find the ones that are, and you just kind of, hey, do you mind if I ask you a couple quick questions? Because, it's the only way you're going to learn things is by asking people that know the answer to the question, people that are better than you at what you're doing. There's really the only way you're going to learn to get better about that. And so from programming, it turned into, I wanted to do some CAD modeling. It's at this point it was, I get a model and we import it into Mastercam, and then we write the toolpaths, we output it, make the parts. And Mastercam was, I haven't used it in years now, but it was so clunky for CAD modeling. It was bad, but that wasn't what it was designed for.
Right.
So, so for me, it was like, all right, I'm ready to expand my tool belt, if you will. I want to learn some more skills here. Knowing that in the future, if you want to build fixtures, if you want to do all these types of things, you got to kind of know how to CAD model. You got to know datum structures. I mean, GD&T, you got to know that really well if you're going to create, good CAD models. And so then it's like, all right, that's the next step. Let's learn some GD&T, start studying that, start getting in the inspection area, start asking inspection questions. And, some of the inspectors that are writing software in Calypso, on the Zeiss CMMs and all that. So it's learning all these things. And then at some point, I'm like, if I'm going to get better at CAD modeling, I'm going to have to figure something else out because I can't do it here. Mastercam's clunky for that. And also there's no business need for it at the time. And so, I was probably at this point 25, maybe 26. And I said, I got nothing but free time. Let me go figure out some way to take this free time by doing some side gigs and see what's out there, And I had a buddy at the time who owned a wheel company, and he was it's a pretty small company. He has some designers, and then he sends it off to shops, gets the wheels made. And I just said, you know what? Let me just reach out to him. And the funny thing was, I reached out to him. I said, hey, do you need help CAD modeling? Because I don't know what you're paying, but I'll be way less than that. And he was like, because I had no idea what the hell I was doing. Yeah. And honestly, it was kind of this was a stretch because I'm like, if he agrees to let me do this, I don't know what the hell I'm doing. I got to figure this out and quick, I've got a good eye for design. At least I feel like I do. And I said, I think we can do this. And he said, hey, let's baby steps. Let's take this easy. Let's try one wheel and see how it works out. And the funny thing is, I mean, over the years, I've designed hundreds and hundreds of wheels now, and I still have all the files. And looking back on some of my original designs, I'm like, oh my God, I can't believe we cut that and put that on a car, Yep. and it's there's a lot of trial and error in that. But what was really great about that was my way of saying, this is how I'm going to get better at CAD modeling. I'm just going to throw myself to the wolves and I'm going to figure this out. And so then it turned into, okay, now I'm designing these wheels and I'm making the CAD models. And then I'm talking to the machine shops that are cutting these wheels. And I'm like, hey, let me write some programs for your machines. Like, hey, this is a twofer, make more money on the side. I'm good at programming at this point. I'm getting better at CAD modeling. And then that kind of turned into a fun kind of, call it a side quest, where I'm going to all these different wheel shops. I'm talking to all these different shop managers, and there was a Metal Effects is a local wheel company out here. I think Mike Schott, I think was his name. I think he owns the company. I remember he made a couple wheels for us at the time, and we went to a shop, and I remember walking in that shop, and it's just full of Haas machines. It's got tons of VF6s, big old lathes. I'm like, oh man, this is because to be honest, some of the other shops I've gone to are like, what the hell? These are like Viper machines that have no memory in them. And I'm writing toolpaths with all these dynamic strategies that the files are huge. They don't even fit in the machine, They're
like, you got to DNC everything or cut it up 6 times.
Oh my God. And that's exactly what happened, and then they're getting all pissed at me. Like, what are you doing writing these huge programs? I'm like, what are you doing with those old machines still, but obviously everybody's got their reasons, but anyways, so going over there, it was pretty quick that these guys are clearly, I feel like, and I could be wrong on this, but I feel like there are more machinists that said, hey, kind of what I did. I can machine, I can CAD model. Let's make wheels. Let's buy machines and let's do it. And their wheels look incredible. I mean, if you look at them on Instagram, they look nice. And those guys know their stuff. And Mike had he gave me some good advice. This is when I was using SolidWorks, and I had been doing it for a couple of years now. So I was decent at it. And he showed me a couple little tricks that just changed my world and how I CAD model. And that was really great. And that continued on for a while, doing the wheel thing, all while still working at N2 and doing the machine shop thing. So it was, wake up at 6, go to work all day, come home, hop on my laptop, design some wheels. And sometimes, when I'm getting proficient at doing this, then next thing you know, they're like, hey, can you do like 20 designs in 2 weeks? Can you do this? Can you do that? And I'm like, hell yeah, I can do it. Look at how badass I am, And then this is before all the burnout happens,
Yeah, I was going to say,
like,
you're still young at that point. Like, that makes sense. Yeah.
Yeah. I'll stay up till 3 a.m. doing this. I don't care, And so that was fun. And that's kind of what, it really just from that point, it was just a lot of hard work and a lot of, striving to get good and get better at every single day. It's like, okay, I made this part. Now, how can I make it nicer? How can I make that surface finish? And then you head down that rabbit hole of like, all right, my surface finish is decent, but how does it become great? And so then you start doing all this stuff and playing with different feeds and speeds and trying different toolpath strategies and talking to your vendors and getting different tools in there and trying some different stuff out.
So how did you convince any of these companies to let you machine your own wheels? Because if I had a customer come to me and say, hey, here's a model and also let me program your machines to make it, I'd be like, oh no, we're done. Thanks.
Yeah. So, funny thing about that was my buddy, so the company's called Aristo. He's still around. They're still doing wheels. He's up in the Bay Area now. And so I was doing CAD modeling with him. And then the first shop was in Costa Mesa out here. And he's like, hey, let's see if he'll let you program it. Yeah, we didn't know if he was going to let us do it. And I go over there. Alex was the owner of the shop. And he said, it was that exact hesitation of like, who the hell do you think you are coming into my shop saying this, And I said, and it was one of those kind of had that moment of like, all right, let's see if you're full of shit. I'm going to take a chance on this, write the program, come back tomorrow. Well, so he had it was a wheel for I think it was a Mercedes G-Wagon or something like that. And it was scrap. I think something happened on the lathe up. It was just a scrap forging. So he said, hey, it's still blank. So let's just go ahead and use this. Here's the CAD model for the spun profile. Throw a design in it, write some toolpaths, come back tomorrow. Let's cut the wheel. I'll have it bolted in the machine. When you get off, we'll start it. And I said, all right. I made the most basic 7-spoke wheel I could possibly make because I'm like, I just need to prove that I know how to run a Haas. I know how to run the controller. I know how to write toolpaths. And I did it. And then it was halfway through the wheel. He gave me that look, that side eye of like, all right. And it was like,
cool.
So then the next step was take that design, spice it up because that looks like shit. And and let's see what else you got, So I'm like, all right. Then next thing you know, it's adding all these pockets and all this detail cuts. And then, now this ball end mill's running for 12 hours because I'm trying to prove a point with this mirror surface finish. And, and so the fun thing is that wheel is still in my garage right now. It's garage art. It'll forever be
no way.
The first wheel I ever made. I left it raw. I never powder coated it. And he said, take it. It's yours. And so that'll a little piece of history. So that was kind of cool. Again, all while still making parts at work and, everything we make. So we were making some military products and, night vision systems and things like that. So our parts are small, really small and insane tolerances. I say insane with confidence because I always have this argument with engineers, they're always like, hey, how tight can that machine hold? What's the tightest tolerance? And I always say 10 thou. I hold 10 thou all day long, no problem. And so they go, no, for real. I'm like, okay, 7.5 thou, but you're pushing it. It is a Haas. Don't.
Well, it's because you say, I got 20 inches of X travel and you get a 21-inch part tomorrow.
Yeah.
That's exactly how it goes every time.
Yep. Or it's like that. It's like Facebook Marketplace. Like, hey, I saw you're selling this thing for $2,000, so I'll give you $100 for it.
Uh-huh.
It's like, oh, what is that? 10,000? Okay, here's a 5/10 tolerance. I need you to hold that all day long.
Yep.
So that was what was fun and say fun. It was challenging, but I think that's what makes it exciting. You get bored if you're just making easy parts and the tolerance is wide open. It's just day after day after day. This is not like that. Our company, this is, still talking about into, we were, I think we prided ourselves on how fast we could churn something around, from an engineer's head on the machine, in their hand, sometimes within a day, depending on the size and complexity of the part. And so we took a lot of pride in that. And so it was lots of long hours, lots of long weekends, insane deadlines like it always is. But it never slowed down. Since the day I started, I mean, we went from, I want to say it was 6 machines. We had some super mini mills. I think they were built in like 2002 or something like that. Still trucking though. They were workhorses. Those things were awesome. We had an SL20 and an SL30 lathe, and what else? I think we had another dual spindle lathe. I don't remember what it was because we never used it, and we ended up selling it pretty early on in my career there. But it was, like I said, early on, we didn't have much to do. So then we're doing all this, math and all these different things. And then next thing you know, it's like, okay, now we got parts coming. Now we got to get to work. We got to make this. And then it's like, shit, the parts aren't stopping. They're just more parts. And next thing you know, it's like, all right, we need to hire somebody else. We need to hire more people. And then by the time, I guess we'll kind of get into it a little bit, but I don't know, it's probably 10 years later, we've now got, 18 spindles in the machine and probably 15 guys or in the shop, and 15 guys in the shop. So we grew quick. And then, well, I guess depending on who you ask, I mean, some companies like, oh, really? 13 guys in 10 years, that's not that fast. But, it was some growth. And then the chaos was our company sold to a large aerospace company. So we got bought by, I don't even know, I think they're the biggest aerospace company now because they bought us and then they went and bought all these other aerospace companies. And I've lost track of it now. But I'll never forget, right before this happened, we had a really large production run coming up. And we had the conversation of, I don't think these Haas machines are going to be able to do this in volume. And it's not a knock to the Haas machines. Like I said, I'm still a Haas fanboy till the day I die. I love those machines. But it was more about, automation and things like that. But then we also had the conversation of, some of these parts do have really tight tolerances and all that. So we started shopping around to different vendors and we ended up landing with DMG Mori. And we bought, I think the PO was for 4 NHX 4000s horizontals, 3 NVX 5100s, they're verticals. So that's 7, a DMU 50, and 2 Tsugami Swiss machines on one PO.
Jeez.
And so then
Talk
it was
about
like,
a change.
Oh my God. And it was, I mean, as a machinist and getting to play with all these toys, mind you, our shop, I mean, you've seen pictures of our shop, and our shops have always looked like this. We try to keep them nice, make them look really nice. But as a machinist and getting to play with these toys, and you get to put a PO in for that many machines, you're like, oh my God, this is so awesome, and we get super excited. We got a $250,000 tooling certificate with Sandvik as part of the deal. And I'm like, oh my, it was the best.
Christmas immediately.
Yeah. So while that's happening, the company ended up getting sold to this aerospace company, and they came in, and then that's when shit hit the fan and everything came to a screeching halt. We went from, making, if I needed material, I hop in my truck, I'd run over to Industrial Metal Supply down the street from us, go grab some aluminum, run back to the shop, throw it on the machine, or throw it in the saw, cut it, throw it in the machine, make the parts. To then it turned into, you need material? Oh, well, we've got to send it through our supply chain, and we got to get 3 competing quotes. And, I'm like, I got to make this part today. Like, maybe you'll have the material in a couple of weeks,
Jeez.
And, I don't want to sour on it too much. It was, they owned us for a couple of years, and, it's not a knock to the company. I think what it ultimately came down to was it's an aerospace company that's so large, and they've got sites all over the world, and they've got this operating system and this way that they do business, and it works. It works great. They're making landing gear for airplanes, and those 1 million square foot facilities, it works like clockwork. They got bus stop schedules where it's like, this part is coming off the machine at this time, and the next part's loaded in, But they come in and, we're a pretty small company. We're used to being agile and quick and moving. And they're like, we're going to shove our operating system on you guys. And you guys are going to make this work. We promise, Yeah. Long story short, it didn't work. But, during that time frame, instead of kind of sitting there and hemming and hawing and being all bummed out about it, kind of sucked at first. And you said, hey, you know what? Well, let's see where we can find the positives in this scenario. And so, it's a large aerospace company. There's tons of room for growth. There's nothing but upward momentum here, And so then that's when I started taking on, one of their they do a lot of lean manufacturing principles, 5S stuff. And that's when I got introduced to all the lean manufacturing. And then it was like this spark all over again, like when I discovered programming and my passion for that. And I'm like, oh my God, this is awesome. And so, then you start taking those principles and then you start streamlining the shop, making your processes more efficient, doing all these different things. And now we're at the point where we've got 22 machines in the shop. I think we had 25 or 26 guys in there, and we're running 2 shifts. we're cranking out parts. And so, while all this is going on, you're like, okay, this is great. And then, things start falling apart a little bit. Next thing you know, oh, hey, we're getting rid of you guys. Somebody else is coming in and taking over the company. It's just this constant, uncertainty of what the future looks like.
Right.
All while this is going on, my boss that I've been talking about was still my boss at this time. And he's
cool.
He's approaching retirement. And I knew my role was, once he's gone, I'm sliding into that position. I mean, I knew it. We all knew it. The only problem is with a large aerospace company, they said, hey, you don't have your bachelor's degree, so you can't be a manager. And I was like, well, I've been basically running this shop for the last, 6 years. I've been working here for 10 years. And it was just kind of I get it. I don't really get it, but I get it. You know what I mean? Like I get it. That's their process. I really think it's stupid. But they say, when we get to that, we'll talk about it. We'll see if we can figure something out, But for me, being told that, like, why am I going to stick around then? I don't want to ride this out. If this is my ceiling, I know I can do more.
Right.
And so then Maztech started, and I transitioned over to Maztech, and it was this. Actually, the funny thing is, the second guy, the guy that we hired. So when it was just the two of us, his name was Troy and myself, and I hired a guy that I grew up with. His name's Charlie, who I still work with to this day. When I left, right after I left, our boss Jim retired, and then Charlie took over that position. So it was this moment of like, here I am at Maztech, and I was employee number 4 of the company. So I was
no way.
Really, really early on. And in fact, when I was hired on, they said, hey, we don't really have anything going on. If you want to hang tight for a couple months and just hang out, I'm like, I don't want to hang out for a couple months. I'll start tomorrow.
Right.
I'd already put my 2 weeks in. The really cool thing about it was the guy who owns Maztech was, he knew my boss, Jim. And so we all kind of had this conversation of like, hey, this is happening. Rob is going to leave this company. He's going to transition over here. So there was no hard feelings. It wasn't like I had to go and have this awkward conversation of, hey, I'm quitting. I hate this. It was none of that. I enjoyed every minute of it, even all the ups and downs. But yeah, I started over here and literally had nothing to do. So then I hear Charlie took over that role. And it's that, did I just make a horrible life decision? Did I just screw up my career path and blow it, But again, I'm like, okay, I'm not gonna sulk on this. I'm gonna keep looking forward and make the right steps. While this is going on, Fusion 360 had started popping up, and it was gaining tons of traction. And I'm very proficient with SolidWorks at this point, very proficient with Mastercam. And I said, what if there's software that combines the two? And I know SolidWorks has, what is it, HSM Works or
they have a few plugins now.
Yeah. So, so you can program in SolidWorks, but I said, I'm going to try this out. The other funny thing about this is, being an engineering company, everything was designed in metric, but we machined in inches. So every single drawing that came through the shop, the engineers there use Pro E. And so I'd hop into Pro E, convert the drawing immediately over to inches, and then print it out and take it into the shop. So it's in inches. But it's this weird, it's designed in metric, it's machined in inches, it's inspected back in metric again. It's just this weird, process. And at the time, like, when are you guys going to switch to metric? And my boss said, when those speed limit signs out there read kilometers per hour, we'll switch to metric, And so here I am over at Maztech, and the owner goes, hey, remember that conversation we were talking about with switching over to metric? Well, you lost the battle, because we're all metric here. And this dude's like, there is no ifs, ands, or buts about it. You're switching to metric. And I was like,
oh, wow.
Hey, you know what? Why don't I just make everything change? I'm going to ditch Mastercam. I'm going to jump into Fusion full time. I'm going to switch to metric. I'm going to go to this new shop. And, I said, hey, another challenge for me. And at first, the funny thing was, when an engineer designs something, he goes, okay, well, this feature here is 10 millimeters. This one's 3 millimeters. At least that's the reasoning they give you when they say, oh, this is why metric is so much easier. Except then the engineer's like, oh, this feature is 3.217 plus or minus 4 microns. And then you're like, oh my God. And then I'm using a 1/2-inch tool anyways. So you're just, okay, it's 12.7 millimeters. You just start converting all of your inches over to metric anyways. But then after a while, like everything, next thing you know, you're well-versed in metric. And, now all my conversations are in metric. And we actually recently did a job for a customer. and they designed the part in inches. And we don't normally take in work like this. This was a one-off kind of thing. And it was really funny because, we just jumped right back into, okay, well, we'll inspect it in inches. We'll talk in inches. And so when I'm talking to one of the engineers about his concentricity tolerance, and we're talking about, tenths, he's going, what I need it in metric, and you're like, oh, all right. So it's pretty funny, but you pick it up pretty quick. And Fusion, I mean, I love it. It's so great, and it's making tons and tons of improvements, and it's just getting better and better. But starting over here at Maztech, there was nothing. I didn't even have toolboxes in front of the machines. I had a VF4, a bunch more machines now, but we had a VF4, a VF1, and an ST15. So we had a couple of machines. I had a VF2 as well. We had a VF2. And so I had these 4 machines, and I had no toolboxes. I had no tools. I had no processes. I had nothing. And I said, well, great. When they said I had nothing to do, I got nothing but things to do, because This is all going to take time to develop all of this.
So what were you hired as? Just a machinist or
I was
shop lead?
Yeah, I was hired as a shop manager.
Okay.
And so that was, I could be whatever I wanted to be. I was the only employee. That was my official title, was shop manager. And so what was really cool is all of the webinars and that type of thing that Autodesk was putting out. And God, I'm gonna get killed for saying it. I think it was Rob Lockwood did like a webinar on parametric vices and stocks and all that kind of stuff, or parametric stock modeling and all this type of thing. I think it was him that did it. But pretty quickly on, I started creating all these templates in Fusion. So I spent my days creating templates for programming to make programming more efficient. So you bring the model in, you joint it to your stock, and you've got some preloaded toolpaths. You regenerate them because it's all model aware, and you're now 30% into programming a part, and you've only been working on it for 15 seconds.
Right.
So I spent a ton of time doing that, because a lot of trial and error. I don't know. I've never done it before inside of Fusion. I'm really good with software at this point, but it's just kind of figuring it out. And again, it's one of those things I look back at now and I go, why did I do it that way? I should do it this way now. It's always looking at the stuff I used to do and getting better at it. And then it's talking about, okay, now let's start buying some tooling. Let's start buying tool holders. And then we started hiring some more engineers in, and then product development really started taking off. When I first started, we were actually it was a night vision system for boats, for like big yachts and things like that. And
interesting.
What was kind of cool was I got to machine the housing for it. We still have it. It's not really dead. It just kind of got sidelined because we got so many other things going on now. But so it was this gigantic chunk of aluminum. To us, it was gigantic. I think it was 20 inches by 15 inches by like 10 inches. It was this huge chunk of aluminum.
That's a pretty big chunk. Yeah.
Yeah. And so I T-slot it. I put slots on the side so I could put some toe clamps. I just bolted it straight to the table. And then I made a massive night vision housing out of this thing that has, I think it has 6 cameras in it, 5 cameras in it. And the cameras were, this thing was so expensive. Just the block of aluminum, and I had to go buy an engine hoist from Harbor Freight just to get it into the machine. And the funny thing is, I posted it on Instagram a while ago, but bought this engine hoist, right? I spent all this time drive over to go get it, drill a hole, put the eyelet in the stock. And I go to lift it in the machine, and the freaking legs smack the bottom of the machine. And I was like, shit. So now unload everything, flip it upside down, hop onto Fusion, whip up some CAD models for some billet legs to lower the thing. And so then I'm machining legs. So I still have it to this day. The joke was with all my buddies, because of all the cars that I built, they're like, God, you just have to lower everything, don't you? You even lower your shop hoist. And the funny thing is, I made it so low that when I picked up the material, it bowed the legs and then drug against the floor. So I couldn't even move it. So anyways, getting it in the machine was a nightmare in itself. And then we're running it on the VF4. And the front of the camera has some faceted faces on it. And one of them, you got to tilt it. I think it was like a 40-degree angle or something like that. But this piece of material was so big, I had to write in the code to kind of shift the table off and X a little bit for it to do a tool change. But even that, when the machine would kind of jog over, I'd have to have it jog over and then manually raise the spindle up, load the tool back in, and then start running the program from there just for the clearance I needed,
Geez.
And at this point, I'm probably 20 hours into machining this thing. And, there's some lens pockets on there. It's really, really tight diameters. And I'm like, if I screw this up, the location of it, the diameter of it, this whole thing's scrap, Worked out well. We still have it. It's actually it's kind of one of our crowning jewels, I guess. One of the old things we worked on. It's still there and it works. We actually set it up on a boat and took it out to the ocean and did some testing on it. I've got some really cool videos of it, and it is super cool. And so yeah, so after that, when we started hiring engineers, that's when we kind of shifted gears and kind of back to what we're doing now, which is kind of different optic systems, night vision systems, different things like that. And, so engineers are coming in, then it's, hey, we got parts we need you to make. I'm like, oh, cool. And, I'm the programmer, the machinist, the debur guy. I'm the, I'm doing everything, tapping the parts, and then the next thing was like, hey, why don't we start powder coating? Why don't we start doing Cerakote? Why don't we? So then next thing you know, we're by a powder coating oven, powder coating gun, doing this type of thing. Then the owner was like, hey, you think you could figure out anodize? I'm like, hell yeah, I can figure out anodize. Like, why don't I just throw more stuff on my plate? And so next thing I know, I'm on an airplane to Reno to a company it's these chemists. And what they do is they develop anodizing processes for, companies like Boeing and Raytheon. Like they'll say, hey, we got this new wingtip or something like that. And they'll say, can you develop, here's our anodizing specs that we'd like. Can you develop the process to do that for us? And that's what they did. And they also offer these classes that were really expensive. And you come out and sit with a chemist, and they have a guy that teaches this class. So I show up to it, and it was the weirdest thing because I walk in, there's like 6 people in this classroom. It's me and 5 people from one company. And so first day, we're going through the first half of the day. We stop for lunch, and the teacher comes over to me. He's like, what are you doing here? And I said, well, obviously I'm trying to learn how to anodize. And he goes, well, so the 5 other people from that company, I guess it's a company that's close by to these guys out in Reno. And when they hire these employees, it's one of their prerequisites. They have to go do this class. So they don't want to be there. They're there just to meet their work needs and go back to work. They're not paying attention or doing anything. And I'm over here scribbling down notes. And I'm like, oh, here's what I've been doing wrong this whole time, because I attempted it and I could not figure it out. And I feel stupid for saying that now because I watch so many people doing anodize. I'm like, this is not that hard. But, trying to figure it out on your own, and, wasn't a ton of good stuff on YouTube at the time, is like, I'll just kind of do trial and error. So I go out there and, doing this class, and I loved it. The class was so cool. And then the second day we go in the lab, and then they're like, all right, now we're going to show you how you're doing it. And then I had to talk with the instructor before I left. And I was like, question for you. And I just want you to be honest with me. We're a small company. We're not, they're teaching this class on the molecular level of what anodize is, what it does, different composites of all the chemicals that go in. They're teaching stuff that it's not that I don't care about it. It's very interesting to me, but I'm like, I'm just trying to make my silver parts black. That's all I'm trying to do. It's not something
you're going to think about daily when you're anodizing.
Yeah. I'm not sitting here trying to meet the exact anodizing spec on this. If we're going to do that, we'll send it out to an outside process house that can do it properly. But a lot of our parts, we just want them black. We just don't want them to corrode, so that's why I wanted to do it. And everything we try to do, literally everything in-house. I mean, we design our own software. We design our own circuit boards. We design our own optics. We design everything in-house, and we do as much as we possibly can in-house. And so anyways, so talking to him, he's like, well, I was kind of asking him, does that make sense to you? Does that seem like a really stupid idea for me to do this? And he said, honestly, yeah, it's kind of stupid, because he's like, this isn't one of those processes that you just flip the switch on and you just go to town. You got to make sure the tanks are set properly. You got to make sure the right temperature. There's all these different things. You can't just do it, And so I said, well, that's fine. I got what I needed out of it. And the funny thing is, I'm sure if the owner of our company is listening to this at some point, we're still not anodizing right now. We've gotten so busy, I didn't have time to do it. So it kind of sat aside, and I've got another guy that's going to be taking that process over. So he now has all my notes, and I've kind of sat down with him and said, all right, let me give you the crash course on what I know about it and download this information onto you. So that's one less thing on my plate to deal with. And so, yeah, it's and then next thing you know, after that, it was, hey, I've been looking into Cerakote, and heard about it, never messed with it. And then I started looking it up. I'm like, it's not even that expensive to get into. It's fairly cheap. It's pretty straightforward. And so I ordered a spray gun and some different colors, and I said, let's do this. And I'm like, I don't even know why we're messing with anodize or powder coat. This is the best. Cerakote is so awesome. So now we've got Cerakote, powder coat, anodize. We've got all this stuff in house. And, it's just, then things just start getting busier and busier.
So by this point, was it still just you in the shop,
Mm-hmm.
or had you hired some people?
No, it was just me. And this is a moment they would come in every now and then and be like, hey, are you sure you don't want some help? I'm like, I got this. I got this. It was, and to be completely honest, it was just enough for me to handle because I'm pretty good at machining. So some of the parts we were doing early on were test fixtures. It's like, hey, I need this angle bracket with some holes in it, or pretty straightforward parts. Then we started developing one of our early systems, and some of the parts that were coming across my desk. Just looking through the drawings, I'm like, oh my god, there's a couple parts I wish I could show you. I can't. Some of the stuff I can't show. To this day, still the most complex part I've ever machined, the hardest program I've ever written, but it worked, and it worked flawlessly. And I was pretty blown away by that. But at that point, that's when I'm like, okay, I'm starting to get bogged down now. And so I hired a guy that had left when I was at N2. He left there pretty early on, and then I hired him back to work with me here. And so he and I were, this 2-man team just trying to kick ass and make all these parts, and it was pretty good. And next, I hired a third guy, and now we're okay. Now all these parts that are coming in, these engineers are like, hey, these parts are pretty complex, and I'm looking at them like, it's time for a 5-axis. And I'll never forget, we're sitting in a conference room having this meeting, and the owner looks at me and he's like, are you gonna be able to make this part? And I'm like, I think we're gonna need a 5-axis. And he was like, all right, let's get a 5-axis. And it was
that's awesome.
It was literally, it was that simple. But I also think collectively we all kind of saw the writing on the wall, headed in this direction.
Right. Yeah. You start designing 5-axis parts, you kind of know what you need to do.
Yeah. And at this point, I had done 0 5-axis work. So, I previously mentioned we bought a DMU 50 as part of that big purchase. Kind of a long story what ended up happening with that. But my last day at N2 I was the project lead on getting the shop expanded. So working with all the contractors, get the walls knocked down and build the shop out to accept the new machines. And my last day was the last machine got dropped in place, and I was like, see you guys later. So, that was that. And then from there, they took it over, and the machines were great. They worked for them and everything. So anyways, I didn't have any 5-axis experience. So I said, whatever, I'll figure this out. And, the funny thing, I think it's kind of interesting about simultaneous 5-axis machining is when people talk about 5-axis, they immediately think, oh, you're making turbine wheels, aren't you? You're doing the most complex 5-axis geometry, and it's like, so you get overwhelmed, you see all these programs, you see all these machines dancing around, doing all the demos at IMTS, and you're like, what the hell? That looks intense. Next thing you know, you buy a 5-axis machine and you're like, okay, it's just positional work.
Right. Yeah. You're doing 3+2 like 90% of the time.
Yeah. I'm going to rotate this 90 degrees and drill some holes. I'm going to rotate this 30 degrees and machine this face, So then the funny thing is then the engineers are like, oh, we have 5-axis capabilities. Cool. All the parts. The next thing you know, it's like, guys, you got to chill. I only have one 5-axis machine, So now that thing's overloaded and the VF4, the VF2 are just sitting there, not getting work. So then
the first one was a UMC 500?
Yeah, it was a UMC 750 SS. Okay. So we bought that, and I love that machine. It's been awesome. Unfortunately, the shop where we were at that we just moved out of, the corner of the shop where I ended up putting the machine, I couldn't have picked a worse spot. And the floor was all jacked up, and it was kind of crowned, and towards the back of the shop, it was really bad. And so Haas came in, they placed the machine. And again, I didn't know this, I had Walker Brothers bring the machine. They dropped it, put it on the floor, and Haas comes back next day to start setting it up. And they said, hey, look, we got it into tolerance, but it is barely in.
Oh.
Like the back leg was all the way out and the front leg was all the way in. So it was,
oh no.
And I was like, oh my God.
Thing to hear.
Yeah. And then, okay, well the casting's going to settle. We're going to start machining parts and this is going to settle. And you're like, dear God, I hope it settles into tolerance and not the opposite direction. Right. and thank God it did. So the machine worked out great. A lot of trial and error on my end. When they set up the machine, the MRZP calibration they were using, the tech used he programmed it for a 25.4, a 1-inch ball, but we had a metric ball. It was 25 millimeters.
No.
So all of our, and I didn't realize that until I'm making the part I was talking about, that really complex part. And I'm like, why is this off like 7 thou in one direction. And I'm looking at my program, and I'm not kidding. I'm ripping my hair out going, there's got to be something in my toolpath. Did I leave stock on somewhere? What did I do? And then I'm sitting there and I'm racking my brain. I'm like, all right, I got to call Haas. They got to come back out here. And then so I called them up, and they said here, just run the MRZP again. And I said, okay. So then I pull it up, and that's when I found it. I'm like, oh, there's my problem. So I put it to 25 millimeters, ran it. The machine was flawless after that. The first part after that happened, the part came in perfect. So thank God that happened, But then, you also have that conversation when you're buying 5-axis. Do I need shrink fit holding? Do I need to spend all this money? I was like, again, let's just buy the machine. Let's get it in here and let's just see what we need from there. And then next thing you know, I'm programming everything for that 5-axis machine. For me, it's like, this is awesome. It opens up this whole new world of machining. And then kind of touching on what you're talking about, where it's kind of one big toy shop. That's how everybody looks at our shop, where we get to make all the cool stuff, and I spend a lot of time making, collet trays or just various things around the shop that are going to, help things out. Like one of the guys early on, he wanted to learn some CAD modeling. And I said, all right, let's get you a Fusion license. And he's hopped on CAD modeling, and he designed a handle for one of our 5th-axis vices, to put the handle on, just 3D printed it on. We have a Formlabs Fuse 1, one of their SLS printers.
Oh, cool.
And so we printed it on that. It's nice and strong. And we're still using it to this day. This thing's awesome, So start designing stuff like that, working around the shop. And then, on my free time, I'm like, all right, I got this 5-axis sitting here. What can we make with it? Let's just make something cool. And so I'm a big car guy. We had one of our mechanical engineers was a big car guy, and he road races on his free time. And so a couple of us, we're big into cars, and K1 Speed is just down the street from our shop. So I said, hey, let's have a lap battle. Let's do a time attack so you can get the fastest time, and I'll machine the trophy. So I designed a trophy as just a 5-axis exercise, if you will. Designed it, and it was cool. But I'm like, so that was the first thing. I made this trophy, Cerakoted it, because why not? Got Cerakote too. And then we went and did it, and I'm like, man, this trophy is cool, but it could be cooler. And so I redesigned it, did another one. And so that's still a thing. We still have that trophy. The best part is that engineer who road races, he's also 100 pounds lighter than me and whooped my ass. So,
oh, geez. So yeah, that alone right there.
Yeah. The best part is he's still the current lap battle holder, but he doesn't work with us anymore. And so when he left, I said, hey, just that trophy's for fastest employee at Maztech, so we're going to need to keep that. We're still friends to this day. He's a really cool guy, but that's my trophy now.
That's awesome.
So and kind of funny story about that too is it's on my Instagram actually. I got hit up to make some more of these trophies for the Red Bull MotoGP. I think it was in Austria, and so HJC had contacted me about making these trophies.
No way.
Yeah. And I said, yeah, why not? Let's do it. And so, yeah, so you have to kind of go on. I got a bunch of pictures of it. I have pictures of the process of making them. And then also what was really cool was, Red Bull does tons of media with all this stuff. And there's pictures of all the winners holding the trophies on the podium, which was super cool, And so then, between doing the wheel stuff and kind of getting my name out there, I start getting contacted by like random companies and random people to do stuff. And most of the time I have to turn it down just because it's just out of the scope of things I want to take on. And if I can do it in a reasonable time period and we're not busy right now, I really can't do any of it. We're just so slammed. But Unplugged Performance had contacted me about machining some control arms for their I think they called the Lord Helmet, their Pikes Peak car they were racing. And it was one of those, they called me, hey, we got your number from one of the guys you were doing wheels with. And he said, you're the man, we could talk to you, you can knock this out. And I'm like, okay. So he said, we need control arms for this car. And I'm like, for a model, there's a Model S, P100D, or the Plaid.
Right.
And I'm like, that's a heavy car. It means these are beefy control arms. So I said, I'll tell you what. And I was driving at the time. I'm like, when do you need them? And this is Thursday. He's like, I need them like Monday. And I was like,
of course,
there's absolutely no way I'm pulling that off. But I'm the kind of person that I'm a glutton for punishment. And I have a really hard time saying no to people, mostly because for me, I don't want it to be a missed opportunity. I always want to try to explore different things, and you never know where that opportunity could lead. So I kind of kicked myself for the next 24 hours, and my stupid ass called them back and said, I'll do it. send me the files. Let me look at them. And then he sent me the files like, I'll do the upper arms. I can't do the lowers. They were too big for our machine anyways, but they had another shop that was willing to do it. They said, hey, look, that's perfect. I got another shop that's willing to do whatever arm you don't want to do. I was like, perfect. So I did the upper control arms on it. And that was pretty cool. I actually have one of them. I scrapped one of them during the process because I was trying to do this. I only had, essentially 3 days to do it. So I said, I'm going to write this program and I'm going to tab it off. I'm going to do this super beefy control arm. I'm just going to make tabs. There was not a single flat surface anywhere on this thing. So, there's no way to fixture it. There's really no way. There's ways to fixture it, but there's really no way. I can't make soft jaws for this thing and hold on to it.
Right. Yeah.
So I tabbed it off and I said, do you guys want me to, ball end mill this surface to get these tabs off? Like, just take a freaking grinder to it. We don't care. We need to get this on the car, And I'm not an engineer in the sense of, done very little FEA. So not enough to say I'm confident in it or competent in it, but I saw that arm like, there's no way this thing is going to get destroyed. It's 70-75 aluminum. It's, and then they tell you who's driving the car at Pikes Peak. And you're like, oh my God, you don't want to have this scenario where next thing you know, Randy Popes is flying off the side of Pikes Peak because your control arm failed.
Because of you. Yeah, exactly.
Yeah. And went well. So everything went great and it was really cool. And it was a cool opportunity. Those guys were really cool to me. And, I said, hey, in the future, we'll contact you again if we need more work. It was, haven't really heard from them since they've got their own thing going on and, they've got their own production methods now. But, just another opportunity along the way to kind of expand my abilities and try different things, get my name out there. And,
cool.
Because I think a big part of it is networking, and that's kind of what got me to where I am now is, I spend so much time talking to vendors and talking to different companies and learning new, better ways of doing the things that we're doing every day,
What's the shop look like now? Like, how many people are you and what kind of machinery do you have?
So right now, I don't know the total number. I want to say we're approaching 30 or 40 employees now.
In the shop or in the company?
No, in the whole company. So
Okay.
In the shop, I've got 6 guys in the shop now. And so I hired, actually Charlie, who took over the shop that went end-to-end imaging, ended up going out of business. And for me, that was, I felt bad, but then I was also excited because I'm hiring all you guys. So I grabbed a couple of the machinists, brought them over, one of the programmers, and man, that, because, you get to this point where we're growing so fast. I'm getting pulled in 100 different directions every day. And, interacting with all the engineering department and talking about ways to make the designs more manufacturable and how are we going to do this in high volume. I don't have time to do that and be in the shop all day writing programs. And I mean, our job queue right now is unreal how much work we have. And every Monday morning, we have a meeting where we go over the entire list and we talk about, okay, we only have X amount of time this week. So let's talk about what we can get done this week. Sometimes, like most engineers, that things start to get derailed and you're heading down this path like, well, 3 months from now, we need this. Like, oh, well, guys, let's talk about what we need this week,
Yeah, you're like, I've got 240 hours of manpower this week.
Yeah, exactly.
What can we do?
Exactly. And you've got all these program managers and their program is the highest priority. It's like, I want these parts first. And it's like this constant, okay, let me try to I'm trying to make everybody happy. We've got to get everybody what they need because literally all of these programs are critical to the success of the company.
Yeah.
And I don't ever want a scenario where we're in a meeting and it's we're waiting on the machine shop. I don't ever want to hear that sentence. And so for us, it's like, whatever we got to do to get this done.
Yeah. But at the same time, if everything's on fire, nothing's on fire.
So, it's funny you say that. So Charlie and I, when we were at N2 for a while, we had cubicles next to each other, and we took the center wall down. We called it our super cube, and I had this giant whiteboard, and I was so sick and tired of all these. This is when we were owned by the aerospace company, and it was nothing but program managers there, and so I was so sick and tired of them coming in and telling me everything was hot. We drew a Scoville scale. And I'm like, all right, we've got ghost pepper, we've got tapatio, where on this scale is it hot? And so what I would do is they would come and say, oh, this program, oh, that's definitely a cayenne pepper. No problem. So I'd take my marker and I'd write that program name. So when another program manager came in, they go, oh, this one's that hot. I'm like, nope, because that program is that hot. So it's either hotter than that or it's not as hot as that. And, and they would get so annoyed when you did it. But I'm like, hey, this is, not everything can be hot, because at some point, if everything's a priority, then nothing's a priority.
Yeah.
Exactly. When you do that, then things are going to fall by the wayside. You're going to start missing deadlines or, And I don't ever want that to happen,
Right. Oh, yeah.
So it's just constant, working with these guys, figuring all this stuff out. And I do love working with them. It's such a cool, especially the company now over here at Maztech, we'll sit in conference rooms and it's really cool seeing everybody kind of put their input. I mean, all of our products that we release are going to be, there's some sort of touch of, I feel like every employee in that product, some input, some regard, and whether it's software, whether it's electronics, whether it's optical, whether it's mechanical, and also it's kind of cool being in the role that I'm at, where then they come to me and say, hey, here's a design we got. Is it machinable? And, most of the time it is. We've had a couple of junior engineers along the way. It's like, okay, where do we even start with this design? And it's kind of cool. And then it's also funny too. There's a lot of stuff Fusion can do that Pro E can't do. I don't know what they all are because I'm not super familiar with Pro E. But when you come in, you're like, I'm going to click this feature and just the delete key and just remove this feature. Like, wait, you can just do that from a step model? And I was like, yeah, it's great. And so I'll take their models and, and Fusion recently released, or I guess not very recently now, that, their manufacturing model option and all that. I still hate that. So I just take the model, duplicate it, and then delete all the crap out that I don't want and just have a dummy model.
I'm the same way.
It's just easier
I don't
for
use
me to do it that
manufacturing
way.
model at all.
Yeah,
but the direct editing, I think, is such an undersung hero of Fusion for manufacturing.
Really
it's amazing.
Yeah. So we have, amongst all the employees, so we now have, I guess I need to touch on our Montana factory too. I haven't talked about that yet. Probably about 2 years ago, we had a program that we're working on. It's what on our website, our X4 FCS system that we're coming out with. We needed a place to machine that. And our shop in Irvine was 2,500 square feet. I'm now at this point, we've got UMC 750, the VF4, VF2, VF1, ST15. We then bought an ST25Y, the UMC 500 SS, on top of building out an inspection room. And we had this giant desk, and it's kind of a funny story about this desk. I'm trying to get rid of it. I've been trying to get rid of it for years because it takes up so much floor space, but it was custom made. It's so nice, but it's right in the middle of the shop. I finally kicked the desk out of the shop and we plopped the UMC 500 right where that desk was. And now there's no more space in the shop to move around, And so now,
is the Montana one the one that I've seen on your Instagram that's like in its own cul-de-sac and you guys are building buildings?
Yep, that's the one. So we bought 30 acres of property out there. And what's really cool about that is I got to be involved with that from ground zero. I mean, we're talking to the contractors and pouring the foundation and every step of the way I got to be involved with that. And it's really cool, seeing that. And not only, I mean, our AC ducts or the HVAC ducts, they're painted we have an RAL number for our red. They're painted our Maztech red color, like that one, we pulled out all the stops. That's going to be our showpiece. The concrete is polished concrete. I didn't want any epoxy in there. It's like polished concrete. So it looks good always. And then, so we're like, okay, we're going to plan this building, right? It's going to be 10,000 square feet. We've got plenty of space. So we have, I don't know if I ever uploaded it. We have a drawing of the kind of future plans for that space. We have the one building. There's enough space for 4 more buildings that are planned. And so that's kind of why the road has that cul-de-sac. It's a circle in front of the first building, but they're going to be in a radial pattern. So we built the center building first. So we'll build the next 2 buildings at 45s from that. And so, yeah, we did kind of laid some of the asphalt work, did some parking stuff, and had a cool sign put up the other day in front of the building. And it's seeing this come up, my first trip out there. And again, I was born and raised in California. I've barely been out of the state. And so we're building this factory, and the owner goes, "You're going to move to Montana, right?" And I was like, we'll see, So the funny thing is the first trip out to Montana, it was like, all right, building's just about done. We're 80% done with the building. Their drywall's going up. They're doing some paint work, but we were starting to deliver some equipment out there. So we had bought a Zeiss Contura. So that was getting delivered out there, and a bunch of we have some temperature chambers and that kind of thing for testing, and a clean room out there. So this is all getting built. Like, we got to fly to Montana because you got to unload it from the truck with the forklift and get in the building. I'm like, cool, let's go. It's February and I'm in California. It's 72 degrees. I'm wearing shorts, We land in Montana. It's -8 degrees. It's
geez.
I mean, it was cold. I don't even know how hard it was blowing. And I'll never forget, we get to the factory, we show up, we had rented a forklift. They show up, and we went a warehouse forklift. They showed up with, I forgot what you call these types of forklift, where it has like the boom on it. It's like for putting stuff on roofs of buildings. And I'm like, oh my God. And I've got to unload the sensitive equipment in -8-degree weather. And so we get to the factory, I hop in the forklift, everyone hops in the Suburban, throws the heater on, rolls the window down and goes, you got this, and snot's running down my face. It's freezing to my upper lip. It was hilarious, And that was my first experience with Montana. But also, driving through the valley. So it's about 30 minutes outside of Missoula. And that drive is just gorgeous. Everything out there is just, it's insane. It's like a Thomas Kincaid painting, it's so unreal, where sometimes you're sitting out there going, man, you get some good views out here in California. Don't get me wrong, but it's a different animal out there.
So why was Montana chosen for the factory?
I think the land was pretty cheap out there. 37 acres out in Montana is a lot cheaper than 37 acres in California.
Oh yeah.
So, and there's, the owner has some property out there too. So he spends some time out there, and I think he, just drive by, saw it for sale, and kind of made sense. That definitely comes with the turtles. And, you're, unfortunately, some of the stuff you can only think about so much. I think, I wouldn't call it a problem, but we do everything at 3,000 miles an hour. We don't do anything half-assed. It's like we make a decision and we go. And, I made the joke all the time about our vendors. If you're a vendor for us, you know exactly what I'm talking about. Because when I call you, I'm like, I need this. I'm like, I need it overnighted. I need it like AM delivery. We need it tomorrow, And I feel bad sometimes because it's like, we really need this,
Oh yeah.
And
I understand.
So you find pretty quick who the vendors are that you can count on, who you can't count on, and you stick to the ones that you can, And so we get this building done, and then I said, all right, we got to buy machines. What are we going to buy out there? And I'm like, what are we making? Because, we knew what we were planning on making, but the design wasn't done. So I haven't seen any of these parts yet. And I'm like, well, it's impossible for me to plan a machine shop around not knowing what I'm making. What if we need a shop full of Swiss machines? What if I need nothing but lathes? What if I need nothing but 3-axis machines because they're all simple? I need to know. But instead, we're like, okay, well, we don't know yet. So let's just pick something. So I said, all right, we bought 3 UMC 500 SSs, and we bought the 16-station pallet pools for them. And I went all out. We bought the 15,000 RPM HSK spindles on. We bought the automatic. We bought them basically like, in fact, King Machine was our dealer out there. And they're like, we haven't seen an order like this ever come through here. Like it's like, it was like somebody went on the website and said, yes. Give me all of that.
Pick everything. Yeah.
Yeah. And so yeah, we bought 3 of the UMCs. We bought 2 of the VF2s, the VF2 SSYTs. So you get the extra Y travel, the super speed. And then we bought the pallet pools for those, which were brand new at the time. And that we can get into that in a second. And then I bought 2 ST25Ys with the bar feeders on them. So we got a pretty good mix of machines to kind of handle, a good mix of parts. So, my next step was, okay, now I have to design the shop layout. How are we going to fit all these machines in there? It's 10,000 square feet, but it's 10,000 square feet for the whole building. So I think our shop is, I want to say it's 5,000-ish, 6,000 out there. The rest of we have a clean room and some labs and things like that. And we have a conference room and some small offices.
That's a lot of machinery for 5,000 square feet.
It is, yeah. And so,
especially with the pallet pools, those are not tiny.
Yeah, first off, those pallet pools are unnecessarily large. They are huge. And so I buy these machines, right? And okay, now I know what I'm getting. Now it's time to lay it out in Fusion. So let me start laying this out, right? The perfect layout. It was awesome. And next thing you know, we're getting these calls from Haas. Hey, your VF2 order is delayed. Okay, well, what? A couple weeks? Like, no. Now, mind you, to be fair, we did buy these at the height of the pandemic. Supply chain issues were insane. But it also, we bought, I think we have serial number like 9 and 10 or 10 and 11 of these pallet pools.
Jeez.
So I saw it. I'm like, yep, pallet pool, we need it. And then it's like, and to be fair to Haas, the reason they were delaying it is, and because I drove over to the factory in Oxnard. I'm like, we got to find out where these things are at, and because we have this program coming up. I need these machines. And Haas, they were adamant, like, we're not shipping these until we know they're right. We want to make sure it's right. And they took their sweet time with it. That's for sure. But, we got them. The problem was my UMCs were ready and my lathes were ready. And my VF2s were still months out. So now we have this tough decision to make. Are we going to pay storage for these machines to sit out here? Because they come from Oxnard to get them up into the valley, they go through Salt Lake City. There's a guy out there that kind of stores a bunch of machines. And so our option, because Haas is like, get your shit out of our warehouse, like, because, I don't know if you've been to their factory in Oxnard. It's insane. It's the amount of machines they pump out of there is wild. So the last thing I need is my 5 machines clogging up their shipping area,
Right.
So they said, all right, your machines are going to be ready. They have to leave. So they're either going to Montana into the shop or they're going to go into storage. And we don't want to pay that storage. So I had to change the entire layout of the shop because where I had the VF2s going, you couldn't bring them in after the fact because other machines would be blocking it. So now we're scrambling to do this and that. So I had the lathes installed and the riggers left. So we used Montana Crane came in and moved the machines in and they left. And I was on the flight home and I'm looking through my pictures and I'm like, I don't think I placed those lathes in the right spot. I think they've got to go like 6 more feet towards the wall. And sure enough, I took all the measurements, fortunately. The reason it was hard is I had them at a 45-degree angle. So it's really hard with a bar feeder and a lathe with this giant chip chute coming off the side of it. You're like, it's really hard to pick a point to measure it from, So I kind of eyeballed it where I thought it was. And then next thing you know, like, nope, they're not in the right spot. So then I had to order machine skates, sent them out to the shop. And then I took one of the guys. I'm like, we're hopping on a flight tomorrow. We got to go to Montana, pick up the machine, put it on the skates, push it 6 feet, and then fly back home. That's exactly what we did. So, we got it done. And, now the good thing is the VF2s are there. All the machines are there. They're up and running. We ended up hiring a couple guys out there. So we got some guys kind of moving things along. And then, website it's X4FCS. That's what's all over our website. And we're getting pretty close to finishing up that design. We're just, we want to make sure that thing is perfect before it gets released to the public. And, we're getting ready to turn that shop on. And so, now we're at this point where we've got quite a few programs going on here, along with this commercial system we're going to be doing out there. And we don't have any programmers out there. I only have one machinist. We hired a general manager to kind of oversee the whole site. But what's cool is he's got a good manufacturing background. So he and I get along really well. We communicate really well. And it's cool. They've got a drive to want to do this. And so it's really great. The machinist out there, he's a go-getter. And so it's been great. It's a little tricky, how do you train somebody how to program and run machines remotely? It's always going to be a challenge. So far, it's working pretty good. We ended up reaching out. They ended up finding some contract programmers out there in the Valley that are able to kind of support for now. And so we're definitely looking to hire guys out there, in that area, some programmers and machinists, and that shop will start to grow now too.
Awesome. So where does the Kitamura fall in all of this too? Why Kitamura? You seem diehard, bleeding Haas. So
yeah. So
why Kitamura and where does that come in?
That's a fantastic question. So there was this week where we have this one part that goes into FCS. It's the optical bench. It's the heartbeat of the system. It's the tightest tolerances, this part is tricky to make. And so, if you looked at the part, it's actually it's a pretty simple part, but it's the tolerancing on it, the surface finish on it, everything has to be perfect because if this thing's off at all, this thing doesn't work. So it's got to be perfect. So I said, we'll just do it on the Haas. No big deal. And then you find out, yeah, actually it's kind of a big deal. It's not a knock to a Haas, but the tolerance on this thing, we're talking plus or minus microns on some of these tolerances. And so we're just getting to the point where the Haas couldn't do it. The funny thing about it was where the machine was placed in the corner of the shop, when the sun, around 2:00, when the sun was kind of at the back of the building, it starts heating up that corner of the shop. And the casting would start to shift on the Haas. And then, next thing you know, so you'd come in the morning and you'd dry run the program 3 times just to make sure it's good, stick the part in there, and then, stick it on the CMM and you're watching it get closer and closer. And then bam, it's on tolerance. And you get 4 parts. And then now the sun's up and now it's getting hot. And it's shit, now we're out of tolerance, And again, that's not a knock to Haas. It's just Haas will tell you themselves, that's pushing it for what those machines are capable of. And so we had this tough conversation of okay, how do we make this part? What machine are we going to need? And I went, we're buying a Kern. Because for me, I'm like the ultimate machine, the ultimate toy to play with, and I'm like, I'm going to buy a Kern. And our Haas factory outlet in Montana or in Idaho, they were saying, hey, go talk to Kitamura. So I went out to Montana, did some stuff out there, and then I flew home for 2 days, flew to Chicago for IMTS. And I was like, all right, I went out there by myself. My sole purpose was to find the machine that was going to make this part and buy it. Not like, hey, go out there, let's take a look at it. Go find one that's for sale, because again, we have no patience. It's like, I want to buy this machine, and instead of sending it back, put it on the truck and put it in my shop, And so I walked around, and I brought the part and I brought the drawing with me. And I'm like, I'm going to go talk to every applications engineer for all these companies, I went by Heller and I was talking to these guys, and I'm like, okay, this is ridiculous. The part, I mean, for a size, it's like the size of a computer mouse. It's tiny.
Right.
It's like,
if it fits on a med center, it's a tiny part.
Exactly. That's a good way of putting it, because it's got a very small work envelope.
Yeah.
So I went by Kern. Of course, I'm going to talk to these guys, and they got a 6-month lead time at the time. And I talked to their engineer, and it was really funny because I showed him the drawing, and he didn't mean laugh about it, but he's like, 10 microns. That's nothing on this machine, this will hold this all day long. And to be honest, he straight up told me that I'm not going to lie. This machine's probably overkill, because I think at IMTS they had the
HD.
Yeah. And it was a customer's machine anyways, because I'm like, is this one for sale? I'll buy it. And he was like,
no, it was already Mickey's, and he was taking it off.
So it's funny how when you had asked me to be on this podcast, I went back and listened to some of them. I listened to that one. I'm like, oh, that's his machine. That's kind of funny.
Yeah.
So this is the customer's machine. And I was like, oh, okay. And he said, hey, maybe look at this machine. And then, so I was like, all right. And I went by Kitamura, and it was funny because I'd kind of forgotten about going by the Kitamura booth, and I kind of stumbled into the booth like, oh, that's right, I meant to come by here. And immediately I saw that med center, and I was like, okay. So I kind of peek in, and they had that little football they had on display, and I'm like, okay, that's about the size of the part we're making. So then I start looking in, I'm like, okay, this thing's pretty cool. So I just start talking to them, show them the drawing. They kind of do the same thing. They start laughing like, this machine will do that all day long, So I start looking around, so it's a med center. It's got we have the first customer that bought a 24 station pallet pool for it.
Oh, no.
They had their 12 station pallet pool, but this is their first time with the 20 station or 24 station. It's also got the 120 tool add-on. It's got the chip conveyor. I bought a Rosedale chip filter for it. We bought MP Solutions, the coolant chiller. We're kind of like, let's just give this the best shot it can at making good parts. And so when I'm at IMTS, and I said, all right, hit me with it. What's the price? They hit me with the price, and I was like, oh, wow, that's much more enticing than I thought it was going to be. When you talk
it's really well priced.
When you talk to Kern and you're like north of $1 million, if you option it appropriately, you're like, okay, that's expensive, And so this thing I'm like, okay, I'm definitely interested. So the hilarious thing is, they hand me the brochure for it, right? And I'm like, cool. I talked to him for probably 2 hours, just hanging out at the booth. And then I said, I'm going to go walk around the show, check some stuff out. I text a picture of the brochure to the owner. I'm like, hey, this is a machine I'm looking at, check it out on the website, look at the specs, but I think it'll do it. He called me like 5 minutes later. He goes, you think it'll do it? I go, no, it'll do it. He goes, buy it. And I was like, what?
Oh my goodness.
There's obviously more of a conversation than that, but it was about that quick, and they pulled the sales tactic, and I don't doubt it for a second, but they said, hey, there's like 9 other people in line looking at this machine. And I guess Kitamura had flown some people out just to look at it. And I said, okay, so we got to jump on this pretty quick. Sales tactic or not, it's a machine. It's available. I can buy it and get it in the shop pretty quick. It'll do what I need it to do. And then, so I went back to my hotel, slept it off. And then next morning went back. I was like, let's do it. Sign the papers. And I'll never forget sitting down. I'm like, I thought I was going to throw up. You see these giant numbers and you're like, I'm putting my name on this right now. And this was like my call to make it. Like, this is the machine. I'm guaranteeing this machine will do it, And if it doesn't work, it's not going to go well,
So that's a little bit of foreshadowing, because I remember in your stories when you got it, there was quite a bit of dialing in. So
yes.
Talk to me about lessons learned on holding 10 microns or 5 microns or something like that.
So the funny thing about it is at IMTS, it had, so again, I've come from Haas machines, right? So it's this feeling of like, we bought this machine and now I'm overwhelmed of, I got to learn a whole new controller. I mean, it's a new machine, let alone, but it's a new controller, and it's a Mitsubishi controller with the aromatic software overlaid on top of it. And
right.
So it's this overwhelming feeling, oh my God. So They said, hey, look, it's the first pallet pool in North America. We want to make sure this thing's right. So their North American headquarters is in Chicago. So from IMTS back to their factory, and they said, we need it for like 4 weeks. Is that okay? I'm like, no problem. Yeah, no problem at all. So I said, cool, we're going to take it back. We're going to run it through some stuff. They're also going to put some software back on it because they had some prototype software on it. They were kind of showing what's coming in the future. So they put it back. And then I got the call. Then they came in and said, hey, remember that part we're going to try to make? Yeah, we want to make it in like 2 weeks. And I'm like, 2 weeks? The machine's not even going to get shipped for 4 weeks. And they're like, yeah, we need to get that reeled in a little bit,
Oh no.
So like I said, when I say we go, so the next thing you know, I'm on the phone with Kitamura, like, you guys done yet? You guys done yet? You guys done yet? And, they ended up finishing up, they shipped it out to us. And then began the process of learning the Kitamura and learning what the pitfalls are of being one of the first people to own one of these things. And so, I have to give him credit because it was very frustrating at the time, to be honest, of like 8 weeks of going back and forth so what we did is we made this cube. And so, I've got in the shop here in Irvine, we've got a Zeiss Mikura for inspection. So we've got a really high precision machine to check this stuff. So I said, I'm going to make this cube, and Kitamura sends you this. It's like this spreadsheet, and it's, you kind of machine these pockets in a cube and then take all the measurements. You fill out the spreadsheet, you send it back to them. They do their calculations. They say, hey, change this parameter, that parameter. You're good to go, which was like 6 weeks of going back and forth of that. So then
Wow.
It started getting escalated because even Kitamura is like, okay, something's going on here. We got to figure this out. And Masco, who's our local sales guys, that's who we bought it through. They were in my shop literally every single day for 8 hours a day. I mean, that's why I have to give them credit. They were there every step of the way to support us and make sure we got this right, And honestly, the days of frustration of like, is this machine going to be running soon? I got to make these parts, So we ended up pulling off, it's got a 3R system on it. We ended up pulling it off and found the smallest of chips that was like embedded into the bottom of it. So we took a diamond hone and kind of hit it, and you could see it. I mean, so we're using micron indicators to try to level this thing. If you run an indicator across it, it would jump up like 2 or 3 microns. But this brochure, this will come back to be hilarious because the brochure says positional accuracy within plus or minus 1 micron, right? And I'm like, that's a bold claim.
That really is, yeah.
So at the show, they tell you, well, hey, look, there's an asterisk on that, right? It's in a linear axis. It's on the x-axis, it's on the y-axis, or it's on the z. It's not all of them combined.
Right. It's not volumetric. It's single axis. Yeah.
Yeah. Also, it's like Reneshaw saying their probes are accurate within a quarter of a micron. It's like, yeah, maybe in the perfect environment, and 99% of people aren't running it in that, So you got to kind of take it with a grain of salt, And so, but again, we're trying to hold their feet to the fire. So I'm sending them these results, and they're like, yeah, we're gonna change this, we're gonna change that, but nothing was happening. And it's like, you get to this point, we ended up finding, and it was kind of buried deep in the ladder on the software. There was some parameter that was just out of whack. I think it was the temperature compensation parameter. And so we think what was happening was it was reading the room temperature and just throwing things out of whack. So they caught that one night, did a ladder update, updated it the next morning. I punched the parameters in, and boom, it came out perfect. And once it came out perfect, and I was like, cool, we hit it once, let's do it again. And it did it again and again and again. And I actually had a picture of it. I don't know if it's still up or not. I had a picture of I did like 8 CMM reports back to back to back. And I think one of the dimensions shifted like 2 microns. Every other dimension was within 1 micron. Some of them were perfectly 0. And our Mikura, we have it in a temperature controlled environment. It's accurate. So I trust those results. I mean, we were trying to hold them so tight. They were even, not getting mad at me, but they're like, hey, you're giving us results. Let's just make sure your CMM is good. So then I was getting mad because I'm like, I get it, in perspective. Hey, if we're checking on a machine that's not giving us good numbers, are we just chasing our tail? So at first you get frustrated, like, don't try and pin this on my CMM. But then I'm like, you know what? They got a point. What if it is the CMM? Well, it wasn't CMM. I checked that. That Zeiss is awesome.
My goodness.
Yeah. So they fixed that. And then it was like, man, this is awesome. And then cool. Now we got these cubes done. It's calibrated. This machine's running. Those guys were great, helping us out, get this thing going. Now it's time to make the part. So I load the part on the machine. And again, we're talking programming in Fusion, and Fusion has, I think Breaking Taps has his med center. And he talked a little bit about it with the post out of Fusion and you going through Complete and all that. So it's like, okay, now I got to learn Complete. So sit down with one of the Kidamore engineers for probably, I don't know, 3 or 4 hours over the phone, going through and getting Complete set up, showing me how to use it. And then me start asking, how do I customize things? Like I wanted to do certain things. Like, for example, it's got M8 to turn on the spindle coolant, but on the side, it's also got this kind of curtain coolant. So it keeps the chips from blasting over to where the window is at, where the pallet pool comes in. And I think that runs off an M53. And, Fusion wouldn't output the M53. So I just went into Complete. And Fusion, I believe it's like a through spindle and flood coolant or something like that, puts 2 M codes. And I just made Complete tell it to output those 2 codes. So now it comes on. Fast forward a little bit, we moved to the new shop. They sent an engineer out from Chicago to help set it up, and he actually repinned the connector for me. So now the M8 just turns them both on. So I was telling him how I did. He goes, "Oh, I'll just repin the connector," and I was like, "That sounds great. That seems like a simple solution to the problem." So it wasn't even a problem. It's just how I wanted to do it. So
did that machine end up in Montana then?
So that was initially the plan. The plan was we'll send it to Montana because it's going for the production program. Except for me, it's like, I'm not going to learn this machine remotely, and I'm not going to be flying to Montana every week to go figure this thing out. And in hindsight, it was the right call. Don't get me wrong, it was an expensive call because now we have to pay shipping from Chicago back to California. And then if we decide back to Montana, plus all the setup fees, and it's just expensive to move this machine. Turns out it was the right call because it's, taken us a long time. But once we got the part on the machine, then it was like, cool. I got Complete to output the post the way I wanted it to do. Now we're making the part, and there's a pocket, and I'm telling you to cutter comp the tool 3 microns. It's moving at 3 microns. We're using solid carbide 3-flute end mills, and it's doing it. Granted, we were using RegoFix holders, so we bought the power grip setup. We bought the machine, and I'm like I said, we pulled out all the stops on this thing. Like, we're going to give it the absolute best shot to make the best parts it possibly can. So we bought the RegoFix, we bought the coolant chiller, all this stuff. We even bought the Renishaw system. We got an OMP 400, so we got the more accurate spindle probe, and it's so that kind of, and then also Automated Solutions is Renishaw guys helping us out, and they're awesome. They're going to help me. They created some programs for me, some macros and things like that, and then hey, anything you want to do when you get this thing into production, you want it to come in and probe this and do that, we'll come back, we'll work with you, we'll write whatever you want to do. It's like, we're talking a production machine with 24 stations. I want that thing to run 24 hours a day, 7 days a week. I want to have the guy come in, change the parts out on the pallets, and you just run these parts all day long.
Right. Yeah. Any broken tools, all that stuff, or worn tools, anything like that.
Yeah. And once it was dialed in, like I said, the thing is just deadly accurate. It's insane. The craziest part about it was it took us so long to get this thing set up. And then next thing you know, we're like, we've outgrown this building. It's time for the move to another building. And I was like, oh my God, we just got this thing running like 2 months ago, and we're making parts on it. And just the thought of unscrewing one of the legs to knock this thing out of alignment to get it to, I'm like, I don't even want to think about it, So I call up our sales guys. I'm like, hey, so I got some good news. I got some bad news. The good news is I got this beautiful shop, 18,000 square feet, huge growth. This is going to be awesome. Bad news is got to move that machine, and I got to move it. We got to move it pretty quick. And you just hear the on the phone, like just the deep sigh of like, here we go again, And so I said, here's what I want to do. I'll take care of all my Haas machines. I use Walker Brothers for everything. These guys are awesome. They've always done right by us. I was like, I'll take care of all that. I'm just going to send you one PO. I want you to pick it up. I want you to pack it up, pick it up, move it, set it back up. I want to be, I just want one PO for that. Just be done with it, And so, unfortunately, it did take a lot longer than I anticipated. I had all 8 of my Haas machines up and running, making parts within 3 days of being in the new building. And it was another, 4 weeks at this other building. And, there's a lot going on with that. They asked me if they could fly some engineers out from Chicago to train them on it. It's a new machine. We had the first one in existence. So, hey, let's get some training on it in the real world environment. And so there's some time that takes up. It's going to be, just takes time for them to do that. So they're not going to be going as fast as they can, but now it's in the new building. And this time we're like, we're going to build a room around it. And so I posted that today of kind of where we're at with the build out on that area. And so, it was kind of funny. It was a Monday morning. we were in our meeting talking about priorities, and I get the call from Haas that my UMC 500 and my ST25Y were ready for delivery. They said, hey, they're ready. We could have them there Wednesday. And mind you, I had that stupid big desk in the middle of our shop, and I was like, cool. Walked out of that meeting, and that's the call I got. So I'm like, awesome, machine's going to be here in 2 days. And it's like, oh shit, the machine's going to be here in 2 days. I got to get the electrician out here, get power to this thing. We got to get this desk out of here. So I have a picture of it. We placed the machines right in the middle of the shop, and my electrician had already pre-run a bunch of conduit and power and all that on that Monday, Tuesday. And on Wednesday, I'm in the shop. The machines are here now. Walker Brothers dropped them off. And so now we're in the shop, and they come in and say, hey, come with us. We found the other building. We think we want to go look at it. Let's all go take a look at it. And you're like, okay. Mind you, our plan was like, hey, we're gonna ride out the rest of this year in this building. We'll start looking in January. Our lease is up on our building in April. April's when we're making the move. 2 weeks later, this is what I get. Hey, we're gonna go look at this building. We think we found it. So we walk over to what is now our new building, and it was like we all kind of collectively went, yep, it's a huge warehouse. It's wide open space. Big growth from where we were at. But, there's a lot to do there. It has more than enough power. It's an insane, I forgot how many amps the thing has. It's insane how much power this building has. It's more than we'll ever need. So power wasn't an issue, but, there's no conduit or anything. The thing doesn't have AC in the shop. There's no spaces. You got to build out the spaces. So I designed the area where our media blaster room goes. And so inside there, we got media blast, paint booth for our Cerakote and powder coat, plus the oven to bake all that stuff. Next to that, we've got a shock station where we mount stuff to and slam it down and, do a bunch of testing with that. We have a dark room where we do, calibrate sensors. And then we built an area for the mechanical engineers. So we built that area out, and that was like the first area that got built out. And what's being built right now is my material room, the room for the Kitamura, my office, and our inspection room. So should be done in a couple more weeks, but it went from that Wednesday, I think it was that Wednesday, we were talking about it. The following Thursday, we signed the paperwork, got the keys on Friday, and the flooring guys were there Saturday laying down the epoxy.
You were not kidding. You guys move quick.
It's insane. And there's pros and cons to doing that. It's like rip the Band-Aid off, get it done, get back to work. At the same time, it's when all the, oh shit, we forgot to think about this. Oh shit, we forgot to think about that, and then it's like pivot and figure that out real quick, Meanwhile, all while this is going on, we still have parts to make. We've still got a shop to run. I've still got machinists that need to hop on machines and make parts, So it's just this nonstop chaos. But it was great. And literally it was like, I think it was, we packed everything up. We were in the building, I think it was 3 weeks later. It took them 2 weeks to do all the epoxy and let it cure and everything. And then first thing that got brought in were the machines. So that was the picture, my most recent picture, because I don't really post a ton. I post more on stories, but my most recent picture is the old shop once we had removed everything, and the new shop when the Haas machines were in place. And I haven't posted more since then because right now I kind of, the angles I film are very specific because we have crap everywhere. It's such a mess right now. And it's fine. We're working around it. It's a byproduct of doing this as quick as we did and moving an entire company all while still having to meet deadlines. And engineers were working from home remotely while their offices were being moved. And, so it was hectic, but we're here now. And, so now we're at this point where it's like, I've got more work than I know what to do with, which is a good problem to have. I mean, job security, right? If this isn't going anywhere, we're building some of the coolest stuff. It really is cool seeing the stuff that we're coming up with. And then, like I said, so we make a lot of weapon related products, and I'm not much of a gun guy. And it's not that have a problem with guns. I have a toxic obsession with hobbies. If you follow me on Instagram, you know how many mountain bikes I've had in the last year, and the cars I've built are, I have no self-control. And so it's kind of funny. So I choose not to get into it. And also it's that saying of once your hobby becomes your job, it's not fun anymore. Then it becomes, it's just your job at that point. So I kind of an
expensive rabbit hole.
Yeah. And I genuinely like to keep it separate. I just kind of stick to my hobbies that I do like that doesn't involve work stuff. And then, so the cool thing for me is you give me a model and a blueprint, and I'm going to make sure that part's good. It's going to look really good. And that's one thing I try to, work with the guys in the shop now is taking pride in their work and delivering parts that are, like, hey, let's Like sometimes I'll walk around, I'll see some chatter on a part or something like that. Hey, let's clean that up. Is it necessary? Maybe not. It's probably intolerance, but it's about, making some good parts, taking pride in your work, and, not delivering crap. You want to, like, I always tell guys, like, you're putting your name on that. You make that part and you deliver it, and I learned that the hard way, because I used to early on, I delivered some pretty shitty parts, like sometimes my boss would point out like, oh, yeah, you're right. I probably should have taken some more pride in that, And so now, it's funny. Early on, I used to work with my dad at an asphalt company. I was 18. I was this punk kid. I didn't want to work. I wanted to go hang out with my friends on the weekends, and so I used to go out in the field and shovel asphalt, and I was the laziest dude on the crew. And the guys were like, "Can you stop sending them with us?" And so it was that thing. And until I found this industry and this profession, it was like, this kind of what gave me that purpose in life. Stupid as that sounds, it's like I finally found something I could focus all my energy and attention on. And kind of like, my ADD, it's like I could focus on things. I could hyper fixate on numbers and, and, trying to make better parts and make our products, shine. It's funny. We always have this conversation. I'm sure you do it too. I think most machinists do. You look at something that's aluminum, you're holding up somebody's product and you're like, oh, I see how they machine that. Or like, oh man, that looks like shit. Why did they do that? Why would they put their name on that? And so,
yeah, totally.
so I have that in my head when I go to design meetings and we're talking about how we can make things more manufacturable. It's like, well, I want people to look and go, how the hell did they machine that? Or so it's kind of cool to sort of take little tricks like that and incorporate it in some of the designs. And then the engineers like to push the limits and the boundaries of what our machines are capable of. And we found them plenty of times, So
I'm sure. Well, let's answer a couple of questions from the audience. You answered actually a lot of the questions already, but Firmworks and Thomas Likes Lights both were asking about bicycle stuff. Firmworks wanted to know when you're going to add a 1,000-watt rear hub e-bike motor to that custom bike you built your wife.
I saw that. That the funny thing about that bike too is, because I'm sure he's interested in it, was my wife. So again, I have a toxic obsession with these things. When I do a project, I don't half-ass it. It's like, I mean, if you followed me on Instagram, I bought this dirt bike and it was like super, it wasn't even old. It was like a 2020. It was all crusty, like been sitting by the ocean. And I tore the entire thing apart down to the bare frame and redid the entire, every single bearing, every nut. I took every single bolt to my media blaster, blasted into raw aluminum, and then Cerakoted them all. Just because goodness. I'm an idiot. And so I, built some custom wheels for it, put some plastics on it, did all this. And then I finished it. And my buddy's like, all right, let's go take it to the track. And I went out to Paris Raceway and it was fun. And I'm like, I'm going to kill myself. And I can't afford to kill myself. So I sold the bike and I sold it to a good buddy of mine. But that's what I do with my projects. And so one day I was driving down the street. My wife saw this family in our neighborhood riding these Super 73s. And she said, I want one of those. And I'm like, oh, you fucked up. Should have told me that. so literally that was a Sunday night, and Monday morning I found it. I went and bought it. And then I said, do you want to ride it for a little bit before I tear it apart? And she's like, no, go ahead. And then I tore it apart. I didn't, it's just nothing crazy on it. I powder coated the frame for it, custom made the seat and did some things on it. And then I'm like, okay, cool. So then I built two for my boys off some Razor Ramblers. I tore those things down, made those all custom, did some custom graphics on it, and then gave them for their birthdays. And now I have mine, and it's still stock for now. But I'll get to that eventually, with building that thing up. But yeah, so that's how I've always been with my projects. All my cars, they've always been, I buy a car, and like when I had my Mustang, that's the car that I built, and I took it to SEMA a couple of years, and I had a lot of partners on that, and so it was a fun project to build. When I was buying the car, the dealer was like, oh, because I bought it used. I don't care. It was 1 year old. It had 2,000 miles on it. I just wanted to find a cheap one because I didn't. And he's like, well, it's the base model. And there was like holes in the door. Somebody had cut some holes for some speakers. And the guy's like, hey, sorry about the holes. I'm like, trust me, I'll bring this car by in 6 months and you're not even going to recognize it. Like, I don't care about any of that, And so then it turns into snowballs. And next thing you know, I'm cutting up the fenders and putting a wide body kit on it because I thought wide bodies were the coolest. And now, that fad is, unfortunately, it's just getting worse, but there was a time and a place for it. And, and then Whipple, I was partnered with Whipple on a couple of builds. And so I had them powder coat the supercharger neon yellow. And then I was like, man, this thing looks so cool. I just took the hood off of the car. And, I machined some custom valve cover or the valve cover plates for it and did a bunch of stuff and that was actually the first car that I built my own set of wheels for it. So I did it through my buddy's company, and we built a set of wheels for that. And I had the wide body kit made. So we were at the shop and I was cutting up the fenders and it didn't fit because the wheels were too wide. And they're like, oh, you got to take the wheels apart. And I'm like, no, we're going to refiberglass that out. The wheels that's like, I will build a car around a set of wheels. So I'm not going to, it's just fiberglass. Just throw more on there. And so
we'll make it fit.
Yeah. We got it, And then I had that car and I put a roll cage in it for who knows what reason, put some seats in it. And then I eventually was like, I had KW had sponsored the car. So I had some really nice suspension on it. And then for whatever reason, I said, I'm going to put bags on it. And so I put an airlift. That's the stupidest thing I've ever did. But, so I did all that. And then my wife got pregnant. So I had my first son. And then my wife got pregnant with our second son. And I was like, all right, it's time to sell the car. It's got to go away. So I ended up selling that car. And then I bought my F-150, which I just sold fairly recently. But I built the wheels for that truck. And that was actually a wheel that I designed and machined it with a really big company. And it's a true beadlock wheel. I still have the wheels. I sold the truck and I'm like, nope, I'm keeping the wheels. So
that's
unfortunately,
awesome.
I never own another F-150. So they might just hang out in my garage as wall art. I tried selling them one time, which was stupid. I should just keep them. But also the amount of money, the forgings, they're based off of a KMC trophy truck forging. The forgings were expensive. The machine time was expensive. My time to design it and do all that was expensive. And so I'm like, if I was going to try to recover my money out of this thing, it's like, they're going to sell them for way too much money. So I'm just going to keep them, and just admire them. And so it's kind of cool.
Awesome. Well, Thomas Lights asked, what lessons of engineering, design, and making have you learned specifically from bicycles?
So I guess as far as engineering goes, actually, that was one thing I was kind of messing around with for a bit. I designed my own stem. Actually, I designed a couple of them. I've designed some crank sets and pedals. Some stuff I've just designed. I haven't had time to machine them yet. But I found pretty quickly you can't put holes too close to the edge because I built a stem and cracked it because I had I made it a 6061, which was the first mistake. And then I put some of the holes a little too close to the edge. But, it's really, as far as bike stuff goes, it's especially now what I've noticed is the industry is kind of interesting with that. I feel like with software like Fusion 360, I feel like it feels so tangible for people, like back in the day, I used to look at this industry and be like, where do you even get started in that? And, maybe that's just me doing this for so long. And, once you do something day in and day out, it just becomes second nature to you. But I feel like, software that's kind of easy to hop on. I mean, the amount of resources that are available now are insane. And so I think it's so awesome for this younger generation of machinists that are up and coming and doing this. And, like learning from older people and that kind of thing. But this industry now is so many people have access to CNC machines and software. It's like next thing you know, all of these companies are popping up. Oh, hey, this company makes stems. Oh, that company makes crank arms. I mean, perfect example of it is Fifth Axis, right? Like, I love those guys. We have Fifth Axis on everything. Like, I love their stuff. But they have a sister company called 5Dev that makes crank arms. They make titanium stems. They make chain rings. And it was so cool because as I understand it, some of the guys that worked for Fifth Axis are mountain bike enthusiasts. And they said, hey, let's make this stuff. And so they took a SRAM, I think there was a SRAM GX crankset. There's like some webbing on the casting on the back side of it. And they kind of punched the holes through and said, hey, this crankset looks cool. And they just did it, I think, as like, look what we can do, And then everyone's like, hey, those are cool. And then next thing you know, like now that company's exploded. They're making all kinds of stuff. They're working with Nico Malali. They're doing he's designing his own frames, and Fifth Axis kind of stepped up with those guys and helped them, the linkage for his rear suspension. They're machining all of that there. And it's so cool seeing that. And as a mountain bike guy and a machinist, it's even cooler seeing that. But so there's a lot of that stuff going on now, And so for me, it's like, I like doing, I'll make one, throw it on my bike, I'll ride it around, and people go, oh, that's cool. I made some cool top caps, just some easy stuff. And then I don't really have any intentions on selling them. I don't have the time to do this in volume like I'd like to. So it's just honestly, it's more just kind of playing around. It's really just me trying to push my limits of CAD modeling, so like I have probably 17 different stem designs, and I machined one of them. And then the other ones, I'm like, that's cool. But what if I change the shape of this? Or what if I change the shape of that? And then it's like, cool, now I got this cool complex shape. How do I machine that now? So it's like, let's start some different 3-axis strategies or some 5-axis strategies, try different tool paths to make things look good, And so for me, it's just more another excuse to kind of play around and kind of hone my skills. And for me, it's like to this day, all I do is ask questions. I want to talk to people. A big part, I love networking, so tons of people in this industry over the years and lots of friendships, especially over the years. And it's been really cool because I feel like people know what I'm capable of. So if they have a question and they know I've got the answer, they'll ask me, and I'm more than happy to help. I will always, to a fault, stop what I'm doing to help people, like literally my boss early on, when the aerospace company took over, I'm like, I'm taking this lean initiative thing and I'm running with it, and I said yes to everything. And there was one day he's like, you got to stop saying yes to everything because you're creating way too much work for yourself. You're getting burnt out. Just take it easy. And also, over the years, you start learning your self-worth. And so early on when I'm doing, I've done machining consulting, I've done CAD modeling consulting, tons and tons. I mean, I don't even know how many hundreds of wheels I've designed. Some of them are for really big companies. Some of them are like mass-produced wheels that are out in the public's eye that I'm like, I sold that design for $350, like an idiot, and they're making millions off of this thing. But it's fine. It's early on. That's what I did. I wanted to get my name out there. I wanted people to know, oh, that's the guy you call when you need that, So I'm like, so I came with this price of like, I'm just going to price it accordingly. I also felt like, how do I price things? Like that's a tough conversation to have because
it's one of the toughest parts of this business, I think.
Because you got to, there's a lot of factors in that. And so early on, I undersold myself. I was like, charging too little for the quality of work that I was providing and the speed I was doing it at. And so at some point you kind of realize, what, this is like, you get older, like I got a family now and there's a lot of stuff. I'm like, no, I know my worth now. And so it's understanding that and charging people accordingly. And, I'm still fair on my pricing. If somebody doesn't like it, it's probably a client you don't want to work with anyways. But I think that's really important, and putting your foot down when they try to take advantage of you, because that's also happened. And it happened one time and never again. In fact, I did a project where we agreed to a price. I showed up with the parts and they tried to undercut me, and they said, hey, how about we pay you this? And then for the rest of it, we'll give you some of our product. And like an idiot, I was like, whatever. I'm not going to sit here and argue with you. Like, this thing's done. I want to move on from it. I got other stuff to do, And then they called me about a year ago to do a project with them again. And I said, absolutely not. And they said, no, this one, you got plenty of time and like kind of unlimited budget. And I told them, I don't care if you paid me $1 million. I will never work for you guys ever again. Knowing damn well if they offered me $1 million, I would have taken it. But the point, it was about, about principle and kind of, like I said, understanding your self-worth and not letting people take advantage of you. And so, yeah, I think that's kind of what I've learned, my older age. I'm only 38, but the longer you do it, it's like
you learn more and more for sure.
Yeah. And like people asking you too, like, man, sometimes, like I was talking to my other programmer the other day and we were talking about how they come in the shop and they go, hey, we need these parts and we need them immediately, And then it's kind of funny because we laugh about like, look, there's two sides to this, right? One of them is that we're really good at what we do. So we kind of make it look easy. And so because of that, I think they take it for granted to a point. But it's also the other side of that is they trust us and they rely on us and they know they can count on us to get it done in that time frame. And so I think there's a lot of pride to be taken in that, So I think that's a lot to this too, especially working for this company and what we do and the speed at which we do it. It's pretty wild. I mean, we're really close to getting this thing released to the public, and it's been a little while coming now, but like I said, it's just the back and forth and making sure this is right. And, it's just, I don't know, there's a lot going on right now, but it's good. It's every day is you come in like, all right, what kind of stuff we're going to get into today, cause it's like, this last week, it's every day. It's okay. Hey, remember that thing that was like the hottest thing yesterday? Well, now there's something that's more important. And you're like, machine's set up on it already. Like, yeah, that's fine. Just break it down,
Yep.
Because favorite thing is the question we get is, don't you guys have tool setters, right? So all you do is you just touch off the tool setter and it does it for you, right? I'm like, I wish it was that easy, And sure, if you guys would listen to me and put everything plus or minus 10 thou, that's exactly what would happen.
Right, exactly. Yeah, I could have standard tools and it would all be done tomorrow. Like, what are you talking about?
Yeah, and that's one thing we do in these machines is that's one of the things I did early on was I created a standardized tool library in all these machines. So inside of Fusion, I've got I've got a library for all my 5-axis machines because all of them share a similar library. And then all my regular 3-axis verticals have that. Kitamura is its own animal. It's got its own tooling and its own thing. But so I've got like on the UMCs, I've got tool 1 through I think 18 preloaded, and I've got thread mills in there. I don't tap anything anymore. I'm so done with tapping. Everything that we tap, all of our parts are M1.6s, M2s, 080s, stuff that the machine, the Haas is like, yeah, sure, we'll tap like 2 of those and then no more. You know, it's just, and that's a hard tap size. So then Harvey Tool comes out with their little tiny thread mills, and I discovered those and started thread milling it, and it was a game changer because now you get that reliability and all this, and you can cut or comp it, you can get go no go gauges. It's like it's so much better now.
And if it breaks, it doesn't scrap apart. You can just load up another one.
Yeah, exactly. Yeah. And you know, I don't care what anybody says. Harvey makes the best thread mills. They make the best key cutters on the market. Their key seat cutters. I love their tools. Their tools are so awesome. So I have an entire drawer that is completely filled of all organized of all their key seat cutters, different diameters, different thicknesses, different neck diameters, just so we have them on hand. Because again, I don't know what the engineers are going to design. So I've got to have a pretty good mix of tools. And we've got metric tooling. I've got inch tooling that I've Trojan horsed into the shop. So I'm like, oh yeah, this is my 9.525 end mill. It's definitely not a 3/8, you know? So it's kind of funny, you know? And honestly, like there's just some stuff that's better in inch tooling, you know? Like we use a lot of helical end mills because they're 1-inch end mills cut like glass. It's insane. I actually posted a picture. We were making, it's actually that ring box that you had posted as the picture on your story. That project was kind of a fun project, but when we were machining the main body for that, we were using a helical 1-inch end mill. And so we had roughed it all out. It was actually for this guy, Charlie, that I've been talking about. He was getting married, and he came to me and said, hey, I want to make this really cool ring box when I proposed to my fiance, or his now wife. And so he had this like STL design similar to what it is. And I was like, cool. He's like, but he was pretty early on here at Maztech, and he didn't have a lot of CAD modeling experience. So he was like, can you kind of help me out with this? And I'm like, where do I even start with this thing? Like if I showed you the model of that thing, it's got these angled slots that a bearing rides up and down on, and it's got this whole traveler that goes up and down. So when you flip the lever, the ring comes up out of the middle. And it's like figuring out the geometry for that and figuring out how we're going to cut this. And so I don't know, 2 or 3 weeks working on this CAD model. And I even did it all so everything's jointed in Fusion, so it's all animated and it all works. And that was for me.
That's awesome.
Again, this another project for me. It's helping out a guy that I've known since I was 15 years old, but also it's like taking my skills and to another level. It's like another challenge for me. And so we machined that thing, but when we were making the body, we roughed it out, and then the diameter was a little bit big. The sleeve that goes in it, it's a really tight fit. And so I wrote him a separate toolpath just to come in and contour that. So he did, finished it off, and then he loaded another block in and pressed start on the controller. No. So the end mill went into, this thing's 4 inches tall, and it went 4 inches tall, just buried the end mill in there. And what's crazy is the end mill didn't break. It finally ripped the piece of material, and we had it in one of those 5th axis, they're serrated jaws. Mm-hmm. And it's only holding on to like 3 millimeters of material, but it just bit into it. The fact that it held on as long as it did blows my mind. And not only that, the end mill didn't break. So that's crazy. I have this picture of a piece of material where it's 4 inches deep, full axial engagement into this thing. And the chips on it were massive. And then it ripped the block out. And so we loaded another block in there, loaded the right program in it, pressed start, and the thing still cut, had a mirror finish on after the fact. Blew my mind. So I'm like, man, that 5th axis work holding too, by the way, like the amount of strength it held on before it failed was insane. So ever since then, because there were some times where I was done, I wouldn't call them sketchy, but everybody else would call it sketchy. We were like, I'm barely hanging on. That's a big piece of material. And like when I made that control arm, that was a huge chunk of material. And I was hanging on to it with that. That was when I'm like, is this going to hang or is it going to rip out? And so now I know where the limit of that grip is. Yeah. And it's a ton.
Not a full axial 4-inch depth cut. I'm good.
Yeah, exactly.
Wow. So well, that brings me to the last 2 questions I ask every guest every week. First one is, what did you research this week? Doesn't have to be machining related. It's just what's been popping up in your browser.
So actually, perfect answer to that is recently Ray's Engineering, they make Volk, like the TE37, everybody knows that wheel. They just released a video the other day of them manufacturing their wheel. And I've been trying to find this video forever because there's some secret sauce to how they do things over there. And they finally
it's
just
super cool.
yeah, now they just let everybody know. And so I wouldn't call it researching it, but I was glued to that. The best part is when they had that knurling tool that comes in to do the beat or the
and it's
the
all
beat
pixelated.
Yeah,
they
like,
won't show you.
And so we're like, oh, look at that top secret knurling tool. You know,
I know. I was thinking that too. The whole time I was watching, I was like, so you're going to show us all of these dies and like talk about how proprietary those are. Like the knurling tool to put a straight knurl into your rim is somehow the real secret sauce. Like
I know, it's so crazy. But yeah, so I was looking at that because, you know, for me, it's like wheels are still my passion. I still really do enjoy doing it. I haven't done it in a while just because this job is like, I don't have really any free time. And when I do, I'm either riding my bike or hanging out with my family, you know? And so it's kind of interesting. So I'm like, every wheel I've ever designed, like I wanted to make an iconic wheel, you know, like that TE37, such an iconic wheel. And I'm like, I want to make something like that one day. So it's been cool. You know, some of the wheels that we've made, they've gone on Ferraris and Bentleys and all these crazy cars. And, you know, after a while, like I said, you do it enough times, you're like, okay, cool. But being a car guy and then also like knowing I modeled that and I wrote that program and, you know, like the other machine shop made it. And it's really not, you know, when you get into it, it's like everything. It's just a piece of aluminum. You stick a tool in it, can make some cuts, you know, out comes a wheel. But, you know, it's a lot of, took me years to fine tune those skills and get better at CAD modeling and doing all that stuff. So, you know, that's something I think I'll always want to research and kind of keep it because that's like, you never know when it's going to come back up and, you know, need some more designs made. So
totally. Yeah, no, it was a super cool video. The other thing that blew me away about it was they showed that deburring tool for the backside of the rim.
Yeah. And how they clocked the spindle around the inside radius there. I was like,
it's not a spinning deburr tool. It's like scribing a radius into the backside of the rim, which is super blew my mind. Yeah,
absolutely. Yeah. And other than that, you know, like I said, we're getting ready to spin back up our anodizing station. So just kind of, you know, refreshing my memory on that. And hopefully we'll start making some parts black pretty soon. So
awesome. Well, the other question I ask is, what are the things you're working on to be a better person, leader, employee, what have you? None of us are perfect. We're all working on stuff. What's yours?
Yeah. So actually right now, you know, it's kind of a big one for me, actually. You know, like I said, my old boss he was more than a boss. He was really a mentor to me. And I've always told guys, you know, I think it's really important for some of these modern machinists and the guys nowadays to talk to these guys. I mean, like, sure, a lot of what they did is old school. Some of it's not being used anymore, but everything that we do now is fundamentally based on what they did back in the day, you know? And honestly, all the principles are the same, you know? Datums are still datums. Those don't change. Inspection, in fact, there's actually some really cool old school inspection methods that you're like, how do you even check that? And then you start researching, like, holy crap, somebody came up with that method, you know? So I think that's really important. And so for me, my boss was always brutally honest with me. And I really appreciated that about him, you know, and I've always I feel like I've been pretty good about being receptive to criticism as well. I mean, really, I know I'm not the best at what I do, and I don't pretend to be the best at what I do. I know I'm good at what I do, but I'll never be the best. There's always going to be somebody out there that's better than you. And I think as long as that exists, I think it's important to learn from that, you know? And so for me personally, as now that I'm kind of in charge and leading this team of guys, sometimes I'll find myself where I still have that machinist mentality where I'm like, I got to program this part and I'm going to go hop on the machine and make this. It's like, no, that's not your job anymore. Like we hired people to do that for you, you know? And so unfortunately what that means is sometimes I don't give the attention to the guys that they need, you know, to kind of like sit down with them and have the same difficult conversations with them that my boss had with me. You know, all the guys in my shop are awesome. Like I've got nothing bad to say about them. I mean, they all work their asses off. And the good thing is we're just dudes that get along. You know, we mountain bike together, we go-kart race together, we go to lunch together. You know, and it's like a sibling rivalry. Every now and then you got guys that are butting heads and you got to like, all right, let's reel it in. You know, we're here to do a job. But I think that's one thing I'm trying to be more cognizant of is kind of taking that step back and really kind of being there for them, you know, like one of my guys had his review the other day and it was like, hey, you know, if there's anything you want to do here, let's have that conversation. I haven't done it yet here at this company because I've just been so focused on, I got to make these parts. But really, I think the culture inside of the shop is arguably more important than the processes you have in place, you know? And it's like I told people there's a difference between cockiness and confidence. You know,
Yeah,
like you can be
100%.
confident that you're good at what you do, but if you're cocky about it, you're not going to learn from it because, you know, you have some guy that's like badass programmer and then it's like kind of a junk program, you know, and then you start
Right.
pointing it out to them and going, hey, you know, you got to do this, you got to do that, or this isn't the way to do that. And they go, well, yeah, they don't want to listen to it, you know? So I think that's always important and I think it's also important kind of on this topic of having that inward look at yourself too, and sort of seeing where I've got room for growth. And I think that's it. I always take the time to sit down with these guys anytime they have questions, and I get long winded. And so when they ask me to show them something in Fusion, I always find myself like, oh shit, I definitely, we're on a tangent now. like, hey, how do I just had this conversation with one of the guys in Montana. He's like, how do I write the program to rework this hole? It was just simple rework, right? But he wanted to learn the in-depth, how do you bring the model in? How do you bring the new model adjointed to the old model so you can compare them? And how do you set your setup, you know, your Z and X planes and all that? So then I start going down like, all right, so here's how you write this program. And then here's how you can do this. And here's how you can do this. Then, you know, you can bore the thing out if you want to, but you can also use and the next thing I know, I'm like, oh shit, they understood it because they did it today and it was successful. But the fun thing is I'm like, man, I definitely need to like, he asked me a question and I was like, just, you know, probe the center line of that thing, write a contour pass, be done with it. But instead I'm like, let me show you 73 different ways to do this, you know? And it wasn't like, let me show you how much I know. It's just like, I've always learned over the years of like, okay, I'm trying to shape this surface. This strategy sucks. It's not doing what I want it to do. Well, right. If you don't have any more tools in your belt, you're screwed, you know? So you've always got to have backup plans. And so I always like try to show people those things. Sometimes I'll like, hey, we'll cover that later. We don't need to go over that right now. But yeah, so I think that's a big thing is trying to stay on target, you know?
Well, I mean, we've been talking 2 hours now. I think it comes across that you just clearly have a passion for this. And I'm sure your guys know that too, that you're not trying to, you know, take up their time. It's the fact that you are obsessed with this. And that's a great thing.
It's true. You know, and I can't ever expect these guys to do what I did. I mean, I spent all of every waking minute of my free time when I wasn't at work, I was doing it for free just to learn it. And I can't expect anybody to do that. You know, and we live in this society now where everyone's like, I don't want to work. They want to put in the bare minimum effort. You know, you're going to have those shops where you got the button pushers and they don't want to do anything else. They just want to show up. They want to collect that paycheck and they want to go home. Right. But that's not what I want to do. And I try to lead by example. Like if my passion shows through and, you know, and also what I really like is when these guys run into a problem, instead of going over there and go, what did you do wrong? It's like, cool. What's the problem? Cool. Let's put our heads together and come up with a solution, you know? And I think having more eyes on something, like I have programs now that I'll still write programs every now and then. And one of my programmers is like, oh, hey, what if you did that? And I'm like, you know what? That's actually a really good idea. I like that. Cause you know, you get pigeonholed and thinking about, you know, machining a part, you can do it so many different ways. And there's not one way that's wrong or one way that's right. There's probably a lot of ways that are right. There's also a lot of ways that are wrong. But I think it's also like, you know, you just get so focused on, I'm going to do it this way. I'm going to do it this way. But really like, oh shit, damn it. Why didn't I think of that, man? You know, then you're like, but you also have to understand at that point to not have that feeling of like, man, somebody who's been doing this less than I've been doing it just showed me up. And then you start getting those feelings like, man, am I a fraud? You know, but that's not the case. It's just that it's a fresh set of eyes. It's the same thing we do with engineering and every aspect of this company. Sometimes it's good to get other eyes on it because you get different perspective. And I think that goes a long way with process development and, you know, all these different things that are going to improve the shop.
Yeah, I totally agree. I think it goes back to what you said, confident versus cocky. You know, confident, absolutely. you know you're good, but you know you can improve.
Yeah.
And that's exactly. The other part of that coin. So I totally agree.
Yeah.
Well, Rob, thank you so much for coming on the show.
Problem.
You'll have to come back on.
I'll be more than happy to.
There's so much we didn't touch on that I would love to pick your brain about, but I loved hearing your story. Thank you so much for sharing it.
Oh, no problem. Thanks for having me on. I really had a good time with it.
My pleasure. And thanks to the new Patreon members. Zach, thank you guys for joining the show. Helps me send people like Rob mics and headsets so that you guys have good audio. Thank you all for listening, and I will be back next week.